Okay, hi everyone. It is, what is it, Tuesday, June 13th, 2017. Lucky day for some, because you're at the Keshe Plasma Reactor group. And as every Tuesday night here on the Pacific coast of Canada, I host the Keshe Plasma Reactor group. My name's Rick Crammond, and this is Guy, the famous Guy.
Oh, famous now.
Yes, and now you have even bigger earphones on. That'll make you even more famous.
Big head now. But they're very
His head's getting bigger, and now he needs bigger headphones. I kid. Yeah, that was a harsh prod and not truth at all, actually. He's got a little tiny head. Look, it's only this big, see?
It's very no, I'm bigger. I'm bigger.
Oh, now it's getting bigger.
Ah,
see, you do have a big head after all.
I can work on it.
Thank you, Guy. That was perfect. Okay, let's carry on, but without the comedy here as such. Well, we still haven't. Wait a minute. My live stream seems to be focused on the wrong screen, I believe. What is going on here? Ah, that's what's going on. Let me get live stream hooked up to, whoops, it's not going over. Can it go over this way? Okay, just give me a minute here and see if live stream can.
I refuse to give you the third screen.
Yes, it's refusing, the little devil. See if there's a different way over. Hello, hello, hello.
Can you not move this one there?
This is fun. Move which?
This one there?
Yeah, maybe. Okay, do things backwards. This over here. Bear with me a minute here while I rearrange basically the entire screen. Right, okay, there we are over there now. It kind of works, except I would have to look sideways to see what's going on, but that's kind of okay. Let's get the screen a little better here. All right. Looks like live stream is live streaming. And everything's up and running here. Yay. Okay, finally. You just have to realize the camera's over here and the screen's over there. I should have the camera over there. It's all good. Okay, let's go to a different camera. Let's see what Shandor has up on the screen here. And I'll turn this around so you can see a little better too. And
I just have some games under the sunshine, under the morning sunshine.
Well, that sounds like a lot of a song.
Can't catch with the camera the beauty which I see here. It's too much light for the camera, probably. Oh. So, changing angle, trying. So this is a zinc oxide, washed 5 times. Mine is with table salt, with sodium chloride. Oops. Just to show how much there is a spacing in between every particle, and yet all they are pulling together.
And they're not floating around much at all. There's a definite separation between the stuff at the bottom there.
This is a CO2 there is a storm there as I have shaken it.
It seems to have more, it's a little more flaky and it tends to mix with the water easier. Would that be true?
Yes. So after I shake this one, it takes some time to settle. You will see always particles going up and down in the same time.
Sorry, I had your audio off in the...
sorry, I had my hand covering the microphone, which is in the camera.
Okay, well, how about we do a rerun of the last scenario there and just tell people again what we had, because we weren't getting your audio there, which is kind of critical.
So this CO2 gas is very flaky, so this lot at least. And after it's shaken, often I see for minutes some flakes going up and others going down in the same time. How to find the proper position, maybe like this. This is also washed several times. Now this is the CH3. Its color is more to orange. Oh, it's too much light in the sunshine. And this is also flaky and not powderish, not dust. I think this is a good CH3. And this is another zinc oxide. This time is made with potassium salt. By the way, the bottle is a bit bluish.
Did you notice any difference between the potassium salt and the sodium salt?
Sure, sure. It's more compact with potassium, at least in my conditions. It's like having a stronger gravity. This is with sodium. Oh, I'm shaking it a little, you see? And this is with potassium. Let's do the same movement. It's like something a little more compact. And in the same time, it's floating a longer time. Again, there is too much sunshine. So anyway, I'm washing them. When they are washed, I put them into plasma capacitors. The coils for that nano-coated and washed caustic since a long time. So I made two kind of pieces. Each one ends with coil to be submerged into the water, and the thicker coils, this part will be in water, and this other part, which you see in the bottom, this has the straight center pin, which will go through the middle of the other coils. And here, these will be those which will be the coil part of the capacitor. It's made of thinner wire. And this longer one will be immersed in gas and gas water. So I put back the stop. It's good to keep it in moist condition. And what I found, it's a very good stuff, a good material for the paper part. I found such a standard made in Germany lens cleaners. which when dry goes like this. Originally they have some kind of alcohol with some little perfume, but listen, it's a strong paper, not a soft one when it's dry, and it's all very well absorbent. So I made such a sample on which I tested which length of paper with which length of aluminum foil combination will give the right thickness to fit into the middle of the coil. So it will be easy to put them together. Once I have the model, just I have to cut them at the same size. So this will be my afternoon task, probably, after I finish to rinse a couple of times more the ganses.
And sorry, what was the combination of ganses that you were going to use? What's the proportions and whatnot? What do you have in mind there?
So I share a screen. Just let me find the right picture. Oh, I have too many open. Not that one. So that I close all these image windows and I open a new one. So the guidance was from Alex's system, somehow. Can you see here this drawing? So as an idea of construction, the center pin will be the gravitational and the external coil will be the magnetical in this case. So let's say this part will be the magnetical and this will be, the central part will be the gravitational. So I'll add the gravitational gases, those which contain oxygen, here in this central part. And also I will GANS coat the wire with the same GANS or mixture of ganses. And the magnetical, that which gives, will come here, near to the magnetical coil. And that will be with CH3. Hydrogen being a better giver. And oxygen being a better getter, taker. You see its gravitation is 16 times bigger than that of hydrogen. So this is the common denominator. And now when making plasma capacitors for making GANs out of ganses, I will use here as a gravitational GANS mixture those ganses which will enter into the combination when I'm going to make the plasma capacitor. Just a second, I have to change the tools here. Okay, so let's draw again. So the idea is to have two containers with thin walls, each one with a different GANS. So let's say this will be GANS A, this other to be GANS B. All these will come into an external container which has to be nano-coated inside in order to keep the fields concentrated. And of course it will have here salt water or plasma water. And here I will connect these together with the plasma capacitor. this way. And here will be the GANs, the rolled paper with GANs inside. So this is the basic idea. So now for GANs A and B, it's possible to use the same GANs in different ratios. 1 part in the left side, 3 parts or 5 parts in the right side, or to use other combinations, so for instance, zinc oxide GANs and copper oxide GANs or whatever. So this will go to calculating about what I want to obtain, to find the difference of the field strengths. And meanwhile, let's find something here.
What would the electrodes look like in that last picture you showed, Shandor? Would they just be plates or coil wires? Or
Coil wires immersed into GANs.
And would it be nano-coated wires then?
Sure, sure.
Yeah.
When we connect GANs with matter state, it's good to have if you have an interface to connect GANs with matter state, it's good to have a nano state in between, to have a gradient.
Right.
By the way, I found something interesting, which may be interesting for creating pure CO2. So many of us have made CO2 GANs. Now the issue is if you have the metal plates into the kit, you have the nano-coated copper and you have the zinc, and these are immersed into the salt water. Whatever salt will be there, these are interconnected. Now, willingly, not willingly, besides creating a difference of the field which is extending the space of the nano-copper, which is, let's say, around 59 in value or 59 to 60, which is filtered by the zinc, which is 65. You get a difference of about 6, 7, and the 6 is the number of the protons of the carbon atom. So you create a magnet for the carbon goes in, it gets combined with the oxygen from the water, so you will get here finally the carbon oxide CO2 GANs. Now the issue is that if you put a copper in the water, and the salt water, some particles of copper will be dissolved, willingly and unwillingly. And furthermore, you have here a pool of the fields which are coming from the copper. Maybe I can try this with another color, which acts here, maybe in this area. But in the other portion, maybe you will have some zinc. Because you see, this 5960 is also close to 65, so it pulls also some zinc. And the zinc goes into the water, it combines with the oxygen of air, and you will have a zinc oxide too. So always when we make GANs in this way, we get such a mixture. So now to overcome that, one of the ways would be to place the plates not inside but outside of the container. Now to make a CO2 without zinc, you can just place outside the nano-copper, inside the nano-copper and outside the zinc, but in that case still you have the copper. If you put the zinc inside and the copper outside, maybe you still have the zinc oxide. So now the idea would be to make it in such a way to separate the plates from the water, which makes a big problem because you see the fields of the nano-coated plate extend widely in the environment, but the fields of the matter state do not extend so much, and they have to penetrate the walls of the container. So Mr. Keshe has suggested us to use both plates nano-coated. So to have a nano-coated plate here and a nano-coated plate here, because those fields could penetrate better. So you have here in the middle, in the container, the difference of the fields. Now there is one issue coming. So if you nano-coat the zinc, that will become maybe 61, 62. And the difference between 61 and 62, that will become, and 59, 60, that will become around a difference of 2. So you'll make a trap for hydrogen mainly, not for carbon. And I found for plate of the one side, I found that nickel is very interesting, and on the right side zinc, but both nano-coated. And you see what's interesting, the nickel is made of a combination of 5 isotopes in natural condition. You see isotope 58, and that's about 68% of the natural zinc is made of zinc 58, nickel 58. In case of zinc, most abundant it is isotope 64, it's 48%. But what's interesting, the difference between the mass number of these, it's around 6, it's 5, 9, 9, 8 and whatever. So it's about 6. And if you go and look at the difference between the other isotopes, the difference is always 6. Which is exactly what we need for capturing carbon. Of course, if you nano-coat that 6 may be reduced with about 4–5%, which is not a big deal because even if it's 5.7, it's still more near to 6 to carbon than to anything else. How about this idea? Who will try first? Who can get nickel first? I have ordered from China, so now let's see how fast it comes by May.
The coin, the nickel, used to actually be made of nickel. I don't think the new ones are, but some of the old ones are.
Yeah, but the coins used to have alloy.
Yeah, I think the nickel ones might have been relatively pure. Let me do a little research on that.
Check please, but if you have an old coin, maybe it will be higher worth than a big piece of coin. But who knows? But as far as I remember, the content of nickel could be 60–70% in the alloys for coins. So I mean to use a nickel 99.99% purity and zinc as well.
For example, the American nickel is 75% copper and 25% nickel.
Yeah, so usually in the opposite way.
Canadian nickel, see, where is it here? Why does it say that? Nickel, there it is. Since 1982, the 5-cent Canadian nickels are composed of 99.9% nickel.
Wow, that's a good news for Canadians. But
they've been slowly removed from circulation to be melted by the Royal Canadian Mint because of the they're worth more now, basically.
Yes, and that's why usually there are laws which punish the destroying of money.
Oh, I'm sorry. I think it. Oh, I see what it is. That's the pre-1982 5-cent pieces, which are the 99.9% nickel. The other one, the more recent ones, are actually they're cupro-nickel. It's a copper-nickel alloy and a multi-ply plated steel. So it's different. Before 1982, they were 99.9% nickel. So
yes,
the new ones are 94%, 94.5% steel, 3.5% copper, and 2% nickel.
Yes, you have to understand that nickel is about 4 times expensive than copper.
Yeah, so
Still, it's affordable. So
they lose money making pennies, so they lose 5 times as much money making nickels if they run a nickel.
Exactly.
Fortunately, there's lots of steel around from
coin,
leftover cars from other countries, so they can make steel from that.
If the coin has the name nickel, doesn't mean it's nickel. You see, there's a difference between nickel and Nickelodeon, the cartoon channel on TV.
Okay.
So anyway, from China on Banggood.com, I found for about such a $5 a piece of 0.3 millimeter thickness nickel foil of 100 millimeters by 200 millimeters. So the size of the French envelope. That's about $5 Canadian.
So it's about the size of a good plate that you might want to put in a CO2 box or something.
Exactly. Even larger. Now I'm just waiting for the post office to bring it to the river. So, but maybe somebody else may have nickel and would like to try. So I try to inspire people so others have chance to make it faster than I can do it.
Yeah, is there any comments on that idea? It seems sound in terms of the theory and the way that has been explained and so on. It makes a lot of sense. What do others think of it? Does anybody play with that idea at all?
I really like the simplicity of the way you explain it, Shandor. For me, like a layman, I never really understand the math. Today was crystal clear. I think I really follow what you're trying to achieve there.
Thank you very much. So if I understand something, it's very clear, very simple. I don't need to use complicated words like the academicians because I understand it. If you don't understand, you have to talk half an hour and say nothing. You understand?
Yeah. All right. Well,
Mr. Sender.
Bonjour.
Bonjour. I can ask you a question.
Yes, please.
If I want to have zinc ZNO2, pure ZNO2, can I make with the wireless?
Find the right materials for it.
Because I have a plate of zinc. I put on the water and I put outside the a core of a copper nano coating outside to make have a plasma field at outside. I have a zinc copper. Oxide of zinc inside.
No, for zinc oxide, you don't need to do that. Because you can put the zinc itself into the salt water. It's just zinc. It's no problem.
Yeah.
So you put a zinc plate. Just let me share my screen.
Yeah.
You put a bare zinc plate.
Yeah.
You put a nano-coated zinc plate. Nano-coated zinc plate. So it has a nano coating on the top. For nano coating that, be careful to not use too much caustic. Which gave me the best results was for 1,000 grams of water or 1 liter of water, boiling water. I'm using about 40 grams of sodium hydroxide.
Yeah.
And about 10 up to 15 grams of potassium hydroxide.
Okay.
So this mixture works well. So its concentration is around 5%, and 5% means a lot.
Yeah, yeah, I know, because when I use NaOH about 10 gram and KOH or for 40, the nano coating is go out. I see a little point of the nano coating go out.
Yeah, the issue which some people make that they use some people use 200 grams of caustic for 1 liter of water, so they make it 20% strength, and the strength of 5% in case of caustic, it makes a difference below, at least in case of sodium hydroxide. If the solution is up to 5%, it's corrosive.
Corrosive. Yeah.
And above 5%, it's very corrosive.
Very corrosive, yeah.
So just don't use too much, and you can do a very nice nano coating.
Yeah.
Now you put these plates, you connect them together, you put something to limit the current. You don't even need 4 bands of metals. I used to use 2 nano-coated wire twisted together. And you put it into your salt water. And the nano-coated zinc has its field strength very near to the non-coated zinc. So it starts pulling the zinc atoms from inside, from the surface, towards it. But in the meanwhile, when it's in contact with the water, that freed zinc atom, it gets combined with the oxygen, which is in the water. So it becomes zinc oxide, and it goes at the bottom. It's very easy to make, and you make it very fast.
No, I'm making for my first time. I put only on the salt water, only a plate of zinc only, and I make a core of copper nano coating.
If you have nano-coated zinc, no, sorry.
No, I only get a plate of zinc only.
Just a second.
Copper, I make camera.
Shall I move? It's easier to move the camera than to move the.
Oh yeah, I should. Okay, got it.
Here it is. So you can see. This is a nano-coated zinc plate on the right side. Oh, it's right side for me. If I turn the camera, it will be right for you too. And on the other part, this is a non-coated one. So this is not nano-coated. You see, it's shiny at the end, and this is a nano-coated one. It's darker. Yeah. See, here is the other one. This is nano-coated. This is not coated. And here on the bottom, you see the GANs. You see a lot of amino acid as well. And in case of this one, if we look thoroughly, maybe we'll see some tiny bubbles. Maybe the light is not the best for it. So here you can see in the corner, after it focuses, maybe some little bubbles which appear. Those will be the bubbles of hydrogen which gets released. So for best result, I should move that and to make space on the other desk. Not that one. This other one. If I'm not shaking it too much. Oh, it's too much light. You see the gas at the bottom? And if you look carefully, you will find here, after it focuses, it's autofocus, there are very small bubbles attached to the wall of the container, but very small ones. It's hard to see them now in this camera angle. Those will grow a little bigger, and when they are many, the creation of gas will slow down because the water will have not enough oxygen. Here you see some bigger bubbles. You see those too.
Do you think those bubbles are perhaps air, or are they oxygen or hydrogen?
It's hydrogen. I suppose it's hydrogen.
Is there any way to test that? I mean, they're too tiny to make them pop, really, but if they were formed into a bigger bubble at the top, you could try to light one with a flame and see if it popped.
Yes, that may be possible, but you need really a small piece of very hot wire. Not a matchstick, but you heat up a tungsten needle, for instance, or a steel needle at high temperature.
No, you can use like, what's nice is one of the little butane torches. So you have a blue butane flame. And if you touch the bubble, if it's hydrogen or HHO especially, then it'll pop.
Thank you for the idea.
Hydrogen will give sort of a fizzy pop, and the HHO, if that was what was created, it will give a really more sharp report of a pop, depending on how big the bubble is. But if it's something maybe, I don't know, a millimeter or so, you should be able to make it pop rather than just making the bubble go away with a flame. You could use even a lighter would work. There's not enough hydrogen to make it explode or catch on fire or anything. It's a very minute amount.
Yes, so I'm trying to use a application instead of Zoom.
Okay, your audio is fading there, Shandor. Maybe you're away from the microphone.
Because I'm talking in the other direction than the camera is. So I'm trying to start a camera application.
Okay.
So let me find the adjustments.
Now we had a while we're at it, Shandor, something that's important that we could add right now is to answer a question that came up is from Carl in the live stream. He says, Mr. Keshe was talking about washing the caustic after the nano-coating process. How should we do it properly? Dropping distilled water on the plates will do the job? Did you catch that, Shandor?
Yes, just I'm moving the camera into another position.
Okay.
So...
you see you now.
With the newest Windows updates, I cannot control now the settings of the camera manually.
It's a feature, not a bug. They don't want humans
controlling through the Skype interface, which I don't like too much.
Yeah, they don't want humans interfering with stuff, so it's a feature, not a bug. Okay, so what would you say? Yeah, what would you say about that question about washing the nano-coated plates after the nano-coating process. You've got caustic on them. How should we do it properly? And he says, just dropping distilled water on the plates will do the job.
Don't drop them too hard because you will damage them.
No, he's talking about dropping water on the plates,
Yeah,
dropping distilled water.
You can them by the edges and then to immerse to one tray of water, then in a second tray of water, in the third. So at least 3 times to wash it with different clean water.
Ah, that's a dishwashing technique, actually.
Yes, or like in the photo lab we had in the 70s when we worked trays of developer and
right.
so on, and between 2 processes always we had to rinse the rest of chemicals.
Yeah, well, that's a good idea. 3 separate containers, and that you have one that's relatively contaminated after a couple of plates, and one that's relatively clean.
You have a container in which you inserted the caustic. You have the plates put or the coils put aligned nicely vertically to not let the water stay still on the top, the second phase. You put the caustic under, you put the hot water, you have the top on it. After that, you have the next process. You extract with a tube, with a pipe, or with a drain. You extract the water. If you don't know how to do that, ask somebody who has a fish tank. He will teach you. And then you make that conditioning period. You put the meter while it is wet. Then you put the top and you leave it for 1 week, 2 weeks, 2 months, how much you want. More layers are better. It will make stronger fields. And at the end, you can choose that again you flush it with water, so you fill all the box with water, and you take it out, and you repeat that 4 or 5 times. It depends on how much caustic you had at the bottom. You can check with a pH indicator or use a pH meter. A pH meter, a cheap one, costs about $10. Or a set of such indicator papers that cost pennies. It doesn't cost too much. So you can check with a pH checker if you reach the proper pH of the water. So that's the way you can do it.
Okay.
It depends how accurate you work with which quantity, because one plate you just can hold it by the edges and to immerse it in the first tray, in the second tray, and the fourth tray, and just to rinse it. But if you make an industrial process with 200 pieces per box, you will not take one by one. It's not practical. Better you flush everything in the box. So you put a lot of water, clean water. Then you pump it out, or you drain it out from the bottom. And then you put a second water, cleaner water, then a third, and so on. It's more practical. But you have to wash out the leftover caustic, because in the next process, when you use the plates, you don't need the effect of caustic. Also, you have to wash against materials also to remove the salts of it, and to do that many times. When you wash them, it is good to have marked containers, what it contains. So this is a copper oxide water, salt water, where I put out this, which is leftover, which is the washing water. So this goes collected. This contains salt, but it's still plasma water. And this you can use, for instance, when you make your next copper oxide gas. Instead of using fresh distilled water, you use that which you used it for washing it. So you save on distilled water. So now you fill again with clean water.
Hi, Shandor. Can I ask a question about that?
Yes, just a second. Do not make me to overfill it over the keyboard. So you put a new water on it. You just shake it well. So you let the water to go through all the particles and wash out the salt. You energize it a little bit. And when you're satisfied of shaking it enough, you just leave it still until it goes again to the bottom and you repeat. So and I used to use a marker and to mark here how many times I washed it. So now this is 3 times washed. This will be the 4th washing, by the way. After you wash it about 5-6 times, it depends on the ratio of water, or 9 times, usually it's salt removed.
Excellent, Shandor. Now, Mark, you had a question for Shandor?
Yes, please repeat. I was busy with other things in the meanwhile, and you were talking far from the microphone.
Yes, hi. I'm sorry. I just had a question because I make, we make so much GANs, and like you said we could reuse the wash down to make the next run of GANs. And I was just wondering, because do you think it would affect, like we try to maintain a level of salt that's in, from the start. That's why I never used it, is I just couldn't figure out how much salt was in that washed down GANs to start a new production.
Yeah, it's an easy way. It's called a TDS meter.
Oh.
Total dissolved solids meter. Which it tells you it's a 500 milligrams per liter or 1000 milligrams per liter, and you add to your formula when you add the salt.
I see. So then it would tell you how much salt was left in the wash down GANs, as you wash it down, like you were showing. You wash it down, wash it down, wash it down. Yeah. Then that meter would tell you how much is left in the wash down part.
Yes, or otherwise you can calculate it. You you have to measure or to note down, because you pull out the GANs into a bottle of known size.
Yes.
So you look at the bottle, it's a 200 milliliters, which is 75% full, for instance, or it's half full, 200 milliliters, it means it's 100 milliliters of salt water inside originally. And then you you are reducing to half that salt so many times, 9 times. Like you add the double quantity of water and you dilute it, because washing is just diluting. And you can count there. So 100 half the 100 milliliters, which you make it half, let's say 9 times. It's divided by 2 first time. It's a 50. Sorry, you have to know also the concentration of how much salt you had. So, for instance, in 100 milliliters, you had 5 grams of salt. So you work on that salt quantity. So you had 5,000 milligrams. Let's go milligrams from here on. Divided by 2, so it's the first wash with double water, it's 2,500. With the second, it's 1,250. So
Shandor, are you showing something now? We don't see any video or anything. Are you showing whiteboard or trying?
But I can share the screen with the copy.
Actually, it might be good to go over that. It's a pretty important aspect of all this. So if we can get a little more scientific with it, that'd be great.
So you have you have 100 milliliters of salt water with the GANs originally. For example, you can calculate with any other figures. And in that 100 grams, you have, let's say, 5 grams of salt. It's a 5% salt. And you wash it 10 times, for instance. So that 5 grams, you halve it. So you have 100 grams of water, you add another 100 grams of clean water. So it means you dilute it to half. So that's 5 grams the first wash divided by 2.5. It's sorry, 5 divided by 2, not 2.5, it becomes 2.5 in the first wash, second wash, third wash, fourth, fifth, sixth, seventh, eighth, ninth, 10th wash. So in 10 washes, you reduce that 5 grams by 1,000 times. So instead of 5%, you will have a 5 ppm, or how to say it. You can't remove completely, but you reduce the concentration of the salt so many times. With 10 washes, if you half it, if you use double water, you reduce that 5 grams of salt finally to 0.005.
But also, if you were to pour off, say, 90% of the liquid in the first time, and then pour in, 90% to make it up.
10 times then, yes?
Right. So it would be 10 times with each iteration, and within probably 3 or 4 iterations, it would be very small concentration. Could you run that for me?
Yes, sir, of course. So 5 grams divided by 10. So dilute it 10 times. First dilution, second dilution, third dilution, and in 3 dilution, you reach the same cleanliness.
Well, I understand that part, but it's the loss of the salt that I'm going to try to replace when I use my recycled water, like the poured off water. I can't understand how much is left over.
It's very easy. It's very easy. Originally, you had 100 grams of GANs together with salt water. That you dilute it as many times as you wish, and you put all the water into the same bucket or into the same container, into the same bottle. Then you see that one, how much water it has. So originally you had a 5% salt in 100 grams, so it means you had 5 grams of salt. So now you look at your bottle or container, and you see, wow, I have 5 liters. That contains 5 grams of salt. Immediately you can divide 5 by 5,000 grams, and by 5 liters it comes 0.001 is the ratio, so it's 0.1%.
So it would make hardly any difference in that case. It would be almost like adding fresh water. You would have to add that much salt to it, right?
Yeah.
Because it's 0.1%.
If you want to go very accurate because you want to keep it exactly at 10 decimals, in that case, of course, you can calculate it easily. It's just arithmetics. Go back to the 3rd elementary class in the school. Okay, go back to the 5th grade. Maybe you had a different school. You don't need too much arithmetics for that. Just how to multiply and how to divide.
Yeah, it's just, I always found it complicated in chemistry, that part of dilutions. I still get this. I still have a problem with the dilution of the hummingbird feeder. It's 4 to 1. So if I add 1 cup of sugar, is it 3 cups of water or 4 cups of water? It drives me crazy trying to remember the dilution factors.
Mathematics are abstract. You work with figures, which don't mean anything. So how much is 3 apples minus 3 apples? 0 apple. There is no apple if it's 0. It means nothing. So it has no sense. But if you learn how to calculate, or you teach your children how to calculate by using beans or corn seeds or apples or bananas or matchsticks, it's much easier for them to understand. For instance, my mother told that when she was in the elementary school, they had a gypsy boy in the class who didn't know how to calculate. If you asked how much is 10 minus 5, he didn't know it. But if they said you have $10 and you give me $5, how much dollars you have left? 5. So when he had such material thing behind, which is interesting for him, he could calculate easily.
Right.
Had no sense.
Okay. We have a question from Jay in the chat. Why is it that you want to get rid of all the salt? Does the amount of salt in GANs affect its field strength? Or is it just for people who drink the plasma waters and a better taste?
It's not about the taste. It's about the action of the fields. So think about, you have a plasma of something, a gas of something, and you put in the mixture something of comparable magnitude in field strength, so they will connect each to the other, so less fields will be available for you. Okay, let's say John can carry 20 kilograms and you give him a 15 kilograms bag. How much he can carry further? So you give a load with that salt. Or shall I be more visual?
Right. Well, definitely salt water is more, has more density, right? And it has a whole different boiling point and freezing point and all of
Everything changes. Of course,
yeah.
Inside the body you have salts, but you see you have a CO2 gas, and this is the gas particle magnified millions of times. So now you add to it a salt. So what happens then in the terms of fields? So carbon is strength of 12, oxygen is 16, and it's a double, it's 16 plus 16, so it has a field strength of 44, let's say, for simplicity. Actually, it will become not 44, but it will become a 33 if it is in GANS state. So it will be reduced in the GAN state to about 75% of the matter state. And now you add, for instance, sodium, which is 23.
Now, also, will the sodium and the chlorine be separated in the water? It'll be as ions or separated, sodium ion and chlorine ion.
Sodium, thank you, Rick. So this was the next step. Chlorine, it's a negative ion. And you have here a gas, which is 33, field strength 33, and you have the chlorine, which is 35. So now 33, it's very near in field strength with 35. So
exactly, that's a really important point, Sandor.
So you have here the CO2, you have here the chlorine, and what you will find that they will match together and they will interlock together in terms of fields. So that will all the fields of the GANs will be looped back into the salt solution. If you remove this salt, then all the fields will be available to go exterior, to go where they should go to make an effect. So instead of having a field of 33, if you match it with a 35, you will get only a strength of 2, which will be free, which is very little in comparison to that 33. So again, in solution, you have a CO2 This is a CO2 gas. So calculating of the field strength. Carbon is 12, oxygen is 16, plus 16 again. So this makes a total of 44. This is in matter state, as a matter. But if you go to calculate the field strength in terms of GANs, in the condition of GANs, in GANs condition, you multiply that with 0.75, or you take only 75% of it, that will become 33. Now,
and the reasoning for that, Shandor, just to review, is the like with a nanomaterial opens up the structure more, so we use that factor to reduce its matter level strength, I guess you would say. It's
in case of lighter gases, for instance, CH3, it's not 75%, it will become about 60% or 55% or whatever. The lighter it is, it goes more open.
right, so it's sort of an opening factor, you might say, or whatever. Mm-hmm. Okay, carry on.
You have a sodium ion and you have a chlorine ion. So this is a 23, this is 33. We have made a calculation here. So this is again the CO2 gas. And you have the chlorine. And chlorine, it is 35. So now this 33 it's very near to 35. And the fields which are near each to the other, they can interlock. So they interlock with each other. And you have here two units left only. All these GANs magnetic fields, magnetic gravitational fields, will match the chlorine, and the CO2 GANs will be busy with chlorine. Both his hands will be held by chlorine. He will have not a free hand to give it to you. If that makes sense.
Very graphic, thank you.
You're welcome. So,
what about the sodium? How does the sodium play into this scene, I wonder?
So its field strength is further. It's not near to that. So you have hydrogen 2 and oxygen, which is water. So this is 2, oxygen is 16, so that is 18. So more likely that we'll find a match nearby and not to the CO2 gas. The sodium is not a problem. The chlorine is a problem here. So the fields which are in near or equal strength, they can interlock each with other. These are the basics on the first book of Mr. Keshe. And thank you very much for the good question. Because you don't have to accept something because we say, you have to always ask for why and how it works. So then you understand it well, not because it was told it is so, but because you understand how it works, because how it happens, what's the mechanism behind, what's the physics behind.
Shandor, Daniel asks in the live stream chat, how about using plasma GANs water in the nano-coating process, like CO2 GANs on a copper plate in the NaOH?
You will get a different quality of nano-coating, of course. Try it, observe the results. I never done that. If I would have done, I could share my experience.
Yeah, it's an interesting concept. I'm not sure what to think about that. you have to be careful not to introduce unintended side effects and so on when experimenting that way. But if you understand the theory and try to create that which you wish, if you get what you wish, then that, I guess, it's a successful experiment.
Yeah, you see, you understand when you wash GANS, which is a liquid, it's already in a salt water. Actually, you dilute it, and you dilute it, you dilute it. You can half it, you can quarter it, you can eighth it, and so on, depending how many times you put more water. So you can, from the beginning, calculate how many you need to make a water purity, let's say, of 99.995% or 99.999995.
Mm-hmm. And it doesn't take much to make a big difference. Like, for example, if we were to drink, say you're stranded out on the ocean and you're in your little dinghy, if you were to drink seawater, then you're not going to exist very long, probably. However, if you had fresh water with you and you dilute the seawater 1-to-1, then you could actually exist on it, and you actually get some nutrients from the seawater as well. And it won't kill you, even with a 1-to-1 dilution that way. I think it was 1-to-1. So you would extend your fresh water supply if you were stranded by diluting it with the seawater.
Yes, it
so it's an interesting idea.
It depends on the sea.
Yes, right. In certain seas, there's double.
Japan near to Fukushima, and you are just on the day when they release the tritium water in the sea.
Yeah, that would be a bad day to be out stranded on the ocean there. Yes, or the day of the tsunami would be especially bad. Yeah. That you probably wouldn't be so concerned about your fresh water extending at that point while you're surfing on the tsunami.
So if you go on the sea, take with you a water distiller which works on the power of the sun, for instance.
Mm-hmm. Yes, so.
But be ready also for cloudy days. So you need alternatives.
Bring your plasma water with you. I guess that's the secret. Always carry plasma water. Maybe that'll be the way of the future. Always, instead of the motto, be prepared, it's be prepared with plasma water. It's good for all purposes and get you through an emergency situation. Okay. Is that for your current inspiration there, Shandor?
If there are the subjects.
Is there any other questions for Shandor while we have him on the line here, so to speak? In a fishing sense.
It was another thing that some people who cannot buy zinc because certain reasons. Usually, if you have access to internet and you have a credit card and you are not in a country where a prohibition to import, you can just order from eBay and other platforms, and it's easier to get a $1-2 piece of a big sheet of zinc. Or if you can't get or can't wait and you are in emergency, you can choose such a zinc carbon batteries, D size or R20 size. They say 0% lead added. They never add lead to it. This is just a fancy promotion. Usually they add mercury. It doesn't say about mercury, so you have to know it may contain mercury. So for about $2 or $1, you get, this is maybe $1 worth, a pair of cheap D-size zinc carbon batteries. I will not take it apart now. I took apart yesterday one and I made a big mess. I had to use a lot of washing water for the floor. The first of all, you put on the table a big newspaper which you will throw it away because there will be a lot of black thing which will come out. And just with pliers, you take off the external cover, which is usually steel. This is just steel. And you find below the other part of the stuff, you remove whatever rings or sealings you find inside. And with a hacksaw, you cut, where is the battery? You can cut, first you extract the carbon rod. It looks like this. So you get a carbon rod, which is good for water electrolysis or other experiments. And then you cut it here at the bottom with a hacksaw. And then you use some scissors or shears or such a clips to cut.
Excuse me, Shandor. Mark, can I get you to mute, please? I'm getting feedback through your microphone. And you can open your mic when we have a question and Shandor's done here. Thanks.
From a D-size battery, you can extract a piece of zinc plate, which is about the size of a business card. So in case of emergency, you can dismember such batteries, but be ready that there will be a lot of black thing inside, which you have to scrape it off, and after that you have to wash it. You see, I left the dirt here, so it has to be washed, thoroughly scrubbed. This paste may contain manganese dioxide, carbon, ammonium chloride, and some mercury. So use gloves always when you do that. But with a hard work, worth of an hour, you can get 2 pieces of zinc plate. So you can nano-coat one of them. You don't nano-coat the other. You put them into a small plastic glass or a cup or a food container or whatever. With salt water, you connect them together with a wire, and you can make your zinc oxide.
So let's say we were stranded. Let's say we were stranded on that little dinghy out in the middle of the ocean, and our batteries just, our alkaline or our zinc batteries just ran out. It would be a good pastime maybe to take them apart and get the zinc plate, and maybe combine that with some copper wiring in our connector for our iPhone or something, which is not working so good right then.
Yeah,
and you know, it's possible to create your own GANs out on the ocean with the ocean water if you're stranded. And then from there, you might be able to actually create a source of food with this GANs water to help sustain you and so on. It's actually possible that one might be able to make use of that in an emergency situation. It's kind of a strange idea, but it's not that strange if you were starving and needed sustenance. Alrighty, thank you for those helpful hints for survival there, Shandor.
And by the way, you don't even need copper plates. You can use any copper wire. You just strip them off the plastic. Just a piece of electric cable which is out of use.
I was just thinking too, isn't some of the new Duracell batteries, they're called a copper top. I think they actually have a copper plate-like connection on the top of the battery for better...
It's no worth of spending on that. Just take a piece of cable.
But I mean, if you're stranded on a raft, you may not have the piece of cable, but you might have the battery, a Duracell, that happens to have the zinc and the copper all built into one battery. That would be handy.
If you take apart a cell phone battery after it's discharged, and if you don't put yourself in fire with it, you can take out a very nice, very high purity, oxygen-free copper foil, which nano costs very little.
That's right.
By the way, I posted on my Facebook something long time ago. It was one of our friends who was stuck in a hotel somewhere in the Middle East, and he was very ill, and he needed, by all means, according to recommendations, such a CO2 gas to get rid of the poisoning, because in the hospital they could only give him such a painkillers and so on, but he needed actually zinc and copper oxide gas. And he had a friend who was healthy, and he had to be taught how to make that gas. So he had to go step by step, and then to draw very quickly such an emergency CO2 do-it-yourself kit. So you can get empty soft drink bottles to cut the bottom of the bottle, so you have a number of cups. You can take a copper wire and nano coat it in a Coke bottle, but you have to get some caustic. If you cannot find a chemical shop, you buy from a normal grocery shop such a drain cleaner which contains caustic crystals, and you can do it. Just to nano coat the wires in the Coke bottle. Then you get the zinc battery, you cut it here, you open it, you clean it, you rub it well, and you have your zinc light. So this is something which actually had been used. And our friend is still alive and healthy after that. He was in a big danger. So you can find those details into
Good one, Shander.
one of my photo albums on the Facebook.
All right. Okay, what else do we have happening here? Do you have anything else in your bag of tricks there, Shandor, you'd like to pull out at this time, or
just
shall we?
something for inspiration and discussion? Maybe we can inspire each other. How many people are trying to make dynamic reactors like you did, Rick, and want to fill it with hydrogen?
That was a question that came up with someone that wanted to ask Mr. Keshe how to make the deuterium and tritium and how to use those with the rotating reactors. That's basically what you mean, right?
Yeah, so you have a double core reactor. So it has a external sphere or ball, and you have an inner ball with two separate motors, or just both connected together. It's another model with one single spinning motor, so there are different versions. So here you need a sealing, a simmering, and to use the two motors, for instance, or you have one where you have two balls. I saw recently, it was Mr. Chen Lin, Chinese knowledge seeker, who have a CNC lathe, and he's promoting on Facebook, his Facebook page, such kind of very nicely made reactors. And in one time I saw them presented on CasheFoundationUSA.com web shop as well, but they took it away after we started to promote it. Probably they got too many orders and could not fulfill all. So, but anyway, you think that inside you want to put something like a hydrogen, and the outer to put some other gas. So now I don't know how to make a hydrogen gas, which is in a liquid form. Those of Arizona have Keshe Manufacturing Arizona. They have managed. They have, it was John Bliven who has showed us some black color hydrogen gas, for instance. You may ask him about to reveal. But anyway, one of the methods to get just nascent or atomic hydrogen is to make a reaction of caustic and aluminum. So you have here a bottle. I'm drawing on the left side. You drill a hole on its plastic top. You put a pipe inside. You glue it well to seal it perfectly. You can make a pressure test. From another bottle, you can make another bubbler, for instance, and you can put here such a sodium hydroxide and potassium hydroxide mixture and put a small piece of aluminum. Now I calculated if you put 1 gram of aluminum, that with enough caustic, so you can put excess of caustic, it can produce about 7.5 liters of hydrogen gas, which is enough, 7,600 milliliters of gas at the normal atmospheric pressure and the 20 centigrade temperature. So that would fill a balloon of a diameter of 24-25 centimeters, which is much more than enough for filling such a small ball, which is maybe 1-2 milliliters only. And
yes, I think I calculated something like I was trying to figure out how much hydrogen you get from a square centimeter of aluminum foil.
Yeah, it depends on the thickness of it. So how many milligrams?
Yeah, yeah.
It's a stoichiometric chemical equation. You have to balance the equation to have the right ratios, and then to use the molar mass for everyone. You can calculate that easily. Then you look for the properties of hydrogen, for how much weight, how much volume it occupies. So for instance, from 1 gram of aluminum, you get 0.638 grams of hydrogen in reaction with caustic soda. So now another thing would be to put here also some nano-coated copper and nano-coated zinc inside, which may be very interesting because you see the difference between zinc and copper, it's very little, and it will match with that of hydrogen or deuterium. Or maybe you can do this not in the first, but in the second bottle. On one of patent descriptions of Mr. Keshe, which you can find on that USB key, which has been released in 2012, you will find such a drawing in the illustrations. So two bottles, plastic bottles, like Coke bottles with electrodes here, nano-coating them with caustic soda, and you put a little aluminum inside. And then you release hydrogen. And in the second bottle, that it will, oh, sorry. Oh, sorry, I have to stop the alarm. Here it may create gas of it, but this needs further studies, experimenting, and in different regions you get a different quality of hydrogen.
Also, I'm thinking that if you're talking about deuterium, for example, it'll be quite a bit heavier than ordinary hydrogen gas, and of course the tritium would be heavier still. So if they would tend to mix generally with hydrogen gas, but maybe with this setup there would be more of a separation would occur, and maybe the heavier hydrogen would be you know, gravitationally sort of separated and be toward the bottom of the bottle rather than the top where we normally think the hydrogen would go to.
Yeah, all is possible, but Mr. Keshe told about the importance of the shape, the curved shape of the Coke bottle, because it creates different conditions in this area and in this other area. So the shape may have an importance. But anyway, let's go back to the hydrogen gas. So I say, so maybe can think about, can experiment about to produce the hydrogen and to use then such a nano-coated copper and nano-coated zinc in order to separate it in a gas form. But anyway, this is just an idea. Let's go back just to gas. If you can release the gas, the idea is to fill this inner ball, which is a model, let's say, made of brass. You nano-coat it first of all. It has a screw, the screw has a sealing. And I've heard somebody, the knowledge seekers, who were trying to fill with gas such a small ball, which is closed with a screw. And because the hydrogen just goes up, he said he produced the hydrogen inside. So he put inside, he calculated, made long experiments to calculate how much sodium hydroxide he has to put with how much aluminum and how much water in order to make the reaction not so fast, so to be able to put the plug and to make it to make enough hydrogen to consume all the aluminum, so to not leave aluminum and caustic in excess, and to make not big pressure to blow up the closed pressure container.
Ah, yes, that's probably the most important factor, yeah.
So now instead of that complicated procedure, I'd suggest for that who has such a reactor balls, maybe some people have them, how about to fill it from down? So this is your reactor ball. You prepare your screw with the sealing just to be ready to close it, and you put it in a holder to have free hands. You fix it somewhere in a vise somewhere or with some clips, and then insert the hydrogen gas through a thin needle, like the needles which used to refill the ink cartridges. It's not a sharp needle, but still a needle. So you can feel from down, and because the hydrogen, it's lighter than the air, it goes up, and as it will fill the ball, it will flush away the oxygen and the air, so oxygen and nitrogen mainly. And if you don't know when it is full, you just use an excess. For instance, you use 7 liters for 2 milliliters, so you are sure that a small part of it will be able to flush it out completely. So it's a flush with hydrogen, but you have to keep it with the bottom down. I mean, with the opening at the bottom, even though you will twist it back after you put the seal. So once you filled it, you just put the seal. And now another idea how to make this more efficient. How about to cool down this produced hydrogen by bubbling it in ice water, which is 0 centigrades? Or you can produce even colder cooling mixtures by mixing certain salts in water, but just use pure water, or you add zinc oxide gas and copper oxide gas, which has some fields, which may be interesting. And anyway, you bubble it here through, and you cool it down. And before to fill up this ball, you put that into the freezer and you cool it further. So you put in the freezer your metal ball. When it is cold, you have to work quickly because it will warm up in minutes. So you take it out, you put it quickly on your support. You can extra cool it if you spray some liquid gas on the exterior, like compressed air or whatever, that you have a duster, for instance, for your keyboard. If you press out enough, it will cool it down. It will freeze it, and then to fill it. So you fill it cold gas with cool down gas, and when you put, so it's compressed, its pressure will be different at that temperature. And after you put this plug here, it warms up and it will create a pressure. Just
Oh, yeah. How much pressure will it be, I wonder? Is it going to be too much pressure?
no,
That
no,
would be
no,
quite
no.
a difference.
Just by temperature difference, it will not explode, so don't worry. But if you make a reaction inside and you miscalculated the quantity, so then it really risks to blow it up. So just some subjects for inspiration, for it's not a solution, it's just something to make you think about, to find your own solution.
Yeah, absolutely. Thank you. Absolutely. It's good to refer back. That's the double Coca-Cola bottle reactor. I think that's seen in the Keshe patent.
Yes,
Correct?
yes, yes.
The patent application.
You still can download it from the internet if you don't have it yet.
Yep.
Just Google for it.
And Keshe said that that was a way of creating the atomic hydrogen rather than the molecular hydrogen, which would normally form. So that's an important factor too, is that we want to try to fill, if depending on what your purpose is for filling this reactor with hydrogen to start with. What is your purpose there, Shandor, by the way? After you got your filled reactor with hydrogen and you set it up spinning, what does it do?
Recently in the private classes, we had a presentation of Dr. Rodrigo who told about the successful use of dynamic reactors which have hydrogen in the center ball and CO2 gas in the external. They had very good, very good results in health. So compared to the other kind of health reactors, it brought the same result in a fraction of time.
Okay.
Many applications of it.
Yeah, and one of the prime applications, of course, goes back to the idea of lift and creating that magnetic gravitational plasmatic field with this type of device.
Yeah, if you want to make such a space reactor, you need hydrogen and tritium.
Right, but also
salinity and acidity.
But in the atomic form, not the molecular form, is the key, at least to getting the...
in gas form, you know, tritium is radioactive in matter state, but in gas state isn't. That's a bit.
Okay, so anybody have... what was that? Oh, I see, it's this... zeroing the camera figured out here. Okay, so thank you, Chandra. That was quite enlightening.
You're welcome. Jay McDougall has written in his comment in the chat. He said that my drawing on the left looks a bit like Packard's tomb. Lead a little, yes, but don't forget, not everybody who has a mustache is your uncle. If it's similar, that may mean something. Just a second. So this is a picture of that, which has been shown also by Eric von Däniken in the Memories About the Future, or whatever was the title of the book, and he said it's somebody handling such a spaceship, and otherwise you see it's a symbolism of a body, and it's that cross is the sign of the corn, which is the life-giving plant, and on top they are not planes, it's a quetzal bird. So don't misinterpret these symbols, please. Try to understand according to the culture which created it.
Okay, Jay says, Rick, is there a field given off by the motor itself too, and how would they affect various different ganses, or would the motor fields not matter? Well, the last sentence is the motor fields not matter. Well, the motor and the fields of the motor do matter, I believe, and they are involved with a matter level interaction probably.
Yeah, it's
so there is some consideration. I think they put an insulator or some sort of a series of different materials to insulate.
Rick, you have the solution in your back. You have a belt. You have a motor which drives your balls by the belt. So the motor is far away. Transmission belt.
True, but the belt ended up charging the sphere such that it could produce a 1-inch spark out of it too.
So you need some graphite spray. You need some graphite spray or something to make it, but it makes it slippery too. You have to make it conductive.
I think that's why it does that. It is conductive. It's it's conductive in terms of static, at least. Static, what they call static, or it's like a Van de Graaff
Another way is to extend the axle of the motor for about.
Yeah, but you're right. The belt drive can work too. I've used rubber belts. They don't charge up the spheres like the one belt from Singer sewing machine, which is some special material that acts as a Van de Graaff generator. But normally the O-rings.
Natural leather, for instance.
Right, that could work in other ways. And it does isolate the motor away from the mechanism, which is, I think, a good idea. And like you say, you can use a long shaft, some sort of non-conducting shaft, or there's other methods instead of electric motors as well. You can use an air motor, for example. You could use a wind-up type motor instead of electric, and so on and so forth. However, what they have is these really nicely built, easy to work with electric motors. And it could be that the type of motors that are used are relatively shielded to start with. I found there's quite a variety in these motors. Some of them are fairly well shielded, and they don't give off a lot of fields. Others create a field up to half a meter away or more, depending on how sensitive the equipment is. But even with the general sensor that we use, they can put out quite a field. So it is a consideration, and it's something that has to work into the design and may have to be changed at some point. Mr. Keshe and others, as we've often said, Armin and so on have said, we don't really need motors. You create rotation without the use of physicality motors. So that's something to be looked at. But for now, we do have these motors, and getting those balls of ganzas going with or in this case, like Shandor showed, with the hydrogen and perhaps other inert gases and so on added in, then you spin that, especially in a 2-core reactor, then you're starting to get very much similar, if not the same, as the Keshe patent application for producing lift. So be careful what you wish for out there, and make sure you tie down your experiments. Don't get away on you. It's not so easy to hit that magic combination. So, I mean, just talking like we did about atomic hydrogen versus molecular hydrogen, well, that just gives it a foot up on the conversion process of, that fusion we want to achieve in the center, that free plasma fusion in the middle of it all, where then we can start to work on a higher level with these devices, as sort of getting what's been called finding the ignition key to make all of that work with the atomic hydrogen and other gases around that to support that structure. The whole thing rotates, and you have a a separation of the layers of gases, and each one does its job that it needs to do to add in or take away from the core event that's taking place. So that's what I'd like to shoot for, and that might be available in the next while. I think I'm going to work toward some little more serious lab work, let's say, right, Guy?
Mm-hmm.
He knows what I'm talking about. We'll keep it secret, not secret, but we'll keep it under wraps a bit until we really do manifest the things that we wish to manifest. But let's just say I think it's time to upscale what we've been doing with our reactors and our experiments and so on. All the stuff we've been doing is great, but now it's time to get more of an effect, let's say. Let's see some real effects. Let's see some indications of lift, of lessening of gravity, a reduction of weight, of heaviness.
Levity.
Right? We want levity. Levity is the cure for gravity. So let's see some more of that cure out there and the manifestation of that. That's what we've been shooting for several years here now in the Keshe Plasma Reactor Group and in the Keshe Foundation as far as that goes. And it would be nice to see some of us taking that more seriously and maybe getting some university experiments going or private sector experiments going to do with that. Why not? If not us, who? If not now, when? That's what it all comes down to. And we're not all going to be here forever. Eventually this physicality passes away and we don't get to play with the toys on this planet then. So unless we come back again, unless we're stupid and silly, we happen to come back again. To actually lift off the planet when we pass away. Because think about it. This idea came up the other day for me, and I just like to pass it on, so to speak, when I'm talking about passing on. We think of ourselves in our society, at least, of when you die, you are buried in a coffin, usually, or in an urn or something. You're either burned up or put in a cask. Let's say your ashes. Or you're put in a casket inside of a box and put in the ground 6 feet down. Okay, is that a true vision of what happens when we die? Do we think of ourselves as being buried? Or another way to look at it is that that whole part is irrelevant to what happens when one passes on. The whole idea is that that gets basically, that's not the part that one should focus on. That's not the you, that's the real you. That's just the physicality. And it's true right now as it is in death. So who is the real you? And, the true test is in death. And strangely enough, the only time we get to see our maker is in our death, according to a lot of the religious beliefs. When I was brought up as a kid, I was the same, right? When you die, you see your maker, you get to, that's when you see your maker. Well, that's kind of a funny way of looking at things. It's not death then, it's maybe just a transition, let's say. And focusing on the physicality always kind of gets us in trouble. which goes right back to the motors and whether the electric motors and the fields interfere and that kind of thing. They may interfere on a matter level and create certain fields, but it might be that the fields that are created inside the reactor combination will be of different strength and different quality that will overwhelm or make those other fields irrelevant. It might be that the motor will stop running, for example, because the electricity no longer flows, or it might be that the motor is self-sustaining just from the fields of the other reaction inside the core. And Mr. Keshe has talked about other observations like that in some of his experiments. All right. Okay, maybe that's enough about that for now. I'm wondering if I think his name is Weijian Jin.
Yes, I'm here.
Would you like to present your little presentation now? Or?
Before I present this, I have, 2 weeks before, I have thinking about one thing about reactor. You see, a reactor, a bowl with the gangs, mixed gang inside. You make it turn with the high speed, it become a reactor. Is right? But if the bowl is weight, if you let it turn with the high speed, it can break and everything. You can have his temperature can become higher and everything. Thinking one thing, if I put one ball of magnetic inside, and I make, I have
magnetic. Is that what you said?
Yeah, a ball of magnetic.
Like a magnet, a magnetic ball, a magnetic
ball, a little magnetic ball in the ball with the gang, and you outside you have one motor with a magnet, and you must turn the magnet, a ball turn in the same time. Is that right? You can make.
There's ways you can make magnetic fields, and you can rotate the magnet. Definitely, we've done that. Simple experiments with that with coil type
because if I make, I haven't time to make, but I can say to you, you can make, and you have a result because by definition, the magnetic the plasma field is composed by the magnetic field and gravitational. If the ball magnetic field turns with a high speed inside the ball, he creates the plasma very, very strong.
But the problem is the ball in the very center, because you want at the very center will be the lightest gases will be at the very center.
No,
unless you're working with ganses, perhaps in a liquid. Then the ball is going to be very heavy. It'll go to the outside of the sphere.
A little ball, about 2 millimeter diameter. It's nothing.
It'll still go to the outside. It'll be the heaviest thing in the solution, and it'll automatically go right to the outside of the sphere when it's rotating. Unless you have a pin on it and you rotate it at high speed in the middle of the whole ball, perhaps.
No need, because the little ball is inside the ball. Magnetic ball, and if you have a magnet outside in the motor, you turn the magnet, the ball turns with him in the same speed. Now you can create a reactor very, very strong. Try it. I say you try it and you have a result, not me. Because if I do it,
I've tried to rotate balls with magnets like that. In fact, I've got a couple of funny videos on that. Let me, maybe it's time to drag them out of the closet.
I say to you, Oli, The first, you have one ball. If you put two balls, one in the other, you make the same thing. Put a little ball, magnet ball inside, and you make it turn. You see the stronger of the plasma field is very, very strong. I try it, and you can have
well, it's your idea. You need to try it. I've already got about 1,000 different reactors to try.
No,
and
if I
I've got
try,
a long list that Guy and I have come up with similar ideas and whatnot. But I have tried rotating lots of balls with magnets and magnetic fields and that kind of thing. And it can be done that way. It's true. It might be, and if you think of, it might be that, for example, the CH3 GANs might act as little magnetic balls, and maybe that's all we need in there with the external magnetic fields in order to cause rotation on the nanoscale rather than on the macro scale that we keep sort of shooting for all the time. Yeah. So yeah, that's entirely possible.
Yeah, because I know you have anything, you can do it at once, and you can have a result at once. You have you can do at once, but one thing more: if you put on 3 balls, the same thing in the space, you take only 1 magnet, you have 3 plasma field in the same time. Something very interesting, huh? I know that.
Possibly.
Yeah, why I say it, because I know you have everything. You have again ball, everything. You have only put a little magnet and you try it. I think you have a big news for you.
Okay, I've got. Let me get this set up. I've got a video I'll play in regards to magnetic balls. Let me just get this so I don't have everything available. There we go. And I have to post it. Oops, put this up. This over here, and then do screen share. And it'll be this one. Share computer sound. Pull this out. And just get live stream, so many things to zero in on here. Get the live stream zeroed in on the video. Okay, now what this is a I'm just getting interference with your microphone there, Anuja. Maybe you can mute for the next little bit here while I show this. There, I'll mute you for now there. Thanks, and we can open that up again. So this is called, this is my Sync Science series that I came out with back in 2007. Wow, it's almost 10 years now. And this is called Spinning Magnetic Balls in a Bowl. So I'll let that be as it is. We're talking about spinning balls and so on. And so let's talk about magnetic, or show some magnetics and just sort of go with it here. I forget what it's even about.
Okay, here we have
it might be noisy.
6 neodymium sphere magnets, and we have them arranged on the top of the CD turbine. As you can see here, they were sitting in their on top of the corresponding magnets in the turbine. And I'm just going to spin this up and see what happens here. There they go around.
What I say
Oh,
to
that got
you,
exciting.
what I say to you is different about this one. This one is with the magnet on the cup. I say when you
Yeah.
make a bowl of ping pong and games, you put the magnet inside.
Mm-hmm.
When you put the magnet inside and you take outside one magnet, turn with the high speed, a magnet inside of the bowl can turn with the outside magnet the same speed. Is right? When the
Yeah, but it would be probably against the skin of the ball rather than staying in the middle, though. I would think it'll be
no,
like
no, no.
spinning around.
We don't need it's in the middle or in the bottom. I don't care. But the little magnet, he make a magnet field, and he add with the plasma field, and he make the plasma field stronger and stronger with the high speed. What
Okay.
what I
Yeah,
need
I won't
Okay, we're going
necessarily
to
work
make a
that
movie
way.
of the
We could.
magnetic coupler
This is
acting as
another.
a magnetic stir.
This is another variation that might be some
Okay, turn on the water
inspiration
pressure.
on this, which
Here we go.
is the same magnetic coupling, but instead the magnets are contained in these discs, and then the discs end up creating a
whirlpool forming in the middle.
pumping vortex motion,
Turn up the
actually,
water pressure a little more.
which
See if
could
we
be
can suck
useful.
air through that thing.
You could do that sort of thing inside of
Okay, we're at
inside of a ball.
maximum throttle coming up here now.
In other words, think of the bowl as the ball.
Yep, we're
full of
sucking
games.
air. Okay, we're at maximum throttle. The water's at the top of the container. And now it's spilling over a little bit. It's quite well. And that is quite a magnetic stir. That's the best magnetic stir I've ever seen. Let's shut it down and see what happens. Start up. Wow, look at that thing go. Excellent power for a magnetic stir. I like that.
Okay, so that's just gives another sort of idea on that whole magnetic stirring concept. I've taken that whole concept, and as far as a magnetic connection with being able to stir things, I made a blender attachment, for example. I won't play the whole video, but
see if we can blend something.
I'll turn the audio off. You get the idea that I can create a magnetic coupling to the blender and have it so you can actually where is it? Actually lift it off. It's actually it can be lifted right off the base. There's the base is a rotating magnets, and the blender has a set of magnets that match up to it, so it can blend through that magnetic coupling is the idea. So I played with magnetic couplings for a couple of years, basically, to try, and here's a salad spinner that actually made it into this made it into the world's top engineering magazine, design news magazine. I was the gadget freak of the month with this design, and they came and took pictures and so on. And it's a salad spinner that's powered by the faucet water pressure and a magnetic coupling underneath to the turbine underneath here, the little Tesla turbine that I homemade. Runs on faucet water pressure, and it has that magnetic coupling that I was talking about onto the salad spinner right there. So the turbine's spinning around. The salad spinner is able to actually spin salad with a magnetic coupling, which I think I show removed at the end. Yeah, I can actually raise the whole unit above and it still keeps spinning. So it doesn't need any direct connection. There's no direct connection there. You can actually lift the salad spinner up and it still keeps spinning. So anyway, I'm just sort of promoting my little series here and having fun showing this. And one thing that did come out of this that is kind of important if you're going to be spinning stuff with magnets is the most important thing I've ever discovered, actually.
Rick, one thing, a video you show, you just show is about a centrifuge of the metal. Not I make now is I make a fuel, not a metal, because you confuse two things. I put a ball to make it turn with a high speed to make a magnetic field, and they add with the plasma field, and he can arise the plasma field only. What I want to do.
Mm-hmm.
Two things different, because
I'll tell you what,
when you mix about
can you do, you were going to do what do you call it, share the white screen, the what do you call it, the whiteboard, and maybe you can show what you're talking about on the whiteboard to show how the fields interact, or show how what your concept is there.
Now I want to share screen with you.
Okay, yeah. Let me stop the share.
Yeah.
I was getting a little carried away with all that. But I did have one video that was interesting that that I will get into at one point, but it's maybe not appropriate right now. So, are you able to share there?
I want to share my dubstep. Yes, this one. I won't share my PS, my screen.
So you've got it set up on your screen, and
you see.
Okay, something's coming through here. Just a minute. All right, we see your desktop or your application. Yep, thank you.
I put a new screen, a new one.
Okay.
Okay, you see a white screen. Now?
Yes, good, thank you. Mm-hmm.
Yeah. Now I put the ball for you, ball, like this one. This is a ball of ping pong. I make a ball of ping pong.
Can you maybe adjust your microphone a little bit? I think it's I think your mic's sort of faded out there.
You see the red ball?
Yes, thank you.
This is a ball of ping pong with the gain inside. Now I make the second one. I put a little ball inside with a magnet ball. You see?
Yes. Mm-hmm.
Now outside I have one motor. One motor with a magnet on the top. You see? This is a motor. When the motor turn, only the little ball turn with the same speed of the motor. Is right? when the little
okay, if you have it orientated that way, then the ball will sit, say, at the bottom of the GAN's ball and spin. Yeah.
Yeah. I need only when the ball turns, it makes a field of magnetic change on the ball. If the magnetic field change on the ball, the plasma field in the ball change in the same time. Is right? Before you make the ball fix on the motor and you make the ball turn. Now, I put the little ball, black ball, with the magnet, and I let the motor outside and turn, the ball and the magnet turn in the same time, the same speed.
Yeah.
It creates the field, magnet field. The magnet field play with the plasma field. They transform the plasma field stronger and stronger because the magnet field, when he turns with high speed, he becomes very strong.
It may be good. The original Keshe patent had a possibility for rotating magnets, actually, or rotating magnetic fields inside the reactor like that.
Reactor,
very similar. Now, one thing I would suggest, though, with this is we end up with a similar problem with the electric motor being fairly close to the sphere, not directly connected, though, which is nice. So, yeah, it's and you could use electric fields rather than a motor with a magnet on it to drive that little ball if you wanted as well. You know, you could have. I can't annotate. Oh yeah, I can.
With this way, you haven't to make the ball turn with the high speed. It's more difficult when you let the magnet outside turn with high speed. The first one. Second one, now I reduce it. After 1 minute, please.
It's actually a pretty good idea the more I think of it. It's, I mean, you wouldn't necessarily have to use a ball. You could use a little a rod, for example, too. That would have even more of a vortex effect. It could be a different shape.
Those magnetic stirrer, you know.
Yeah, it's like a magnetic stirrer, basically, but we're talking about micro-sized and higher speed than normal, I think.
It would be really high speed.
You could make it really high speed.
No, because if you put the ball like this one, you have an I haven't work.
Try to say it a different way. That what about the ball?
Il n'y a pas de friction là. They haven't
no friction.
No friction about a ball with the metal because it's round.
That's true. If once it starts rotating past probably around 2,000 RPM, then it becomes essentially a bearing, what do you call it, a liquid bearing under the surface, and it won't touch the surface of the ping pong ball anymore. It'll become a liquid bearing. That's what I discovered with the rotating stuff that I was just showing you in that experiments, that at a certain speed, the turbine, the Tesla turbine I was making that had no bearings, after about 2,000 RPM, it would no longer rub on the case because of the fluid bearing effect that occurs. And that's what would happen with that ball inside the sphere. It'll sort of just float in there in a sense at the bottom. And in fact, once the vortex starts inside, it might start to lift up inside the vortex. I've found that happens as well. The stronger the vortex inside, the more it'll tend to Whoops, I just put a dot in there. Let me clear that.
Now, if you create 3 balls on the bottom and 1 ball on the top, you have a reactor. If you put the motor just in the middle here, okay, yeah, something wrong. Here, when the motor turn, the 3 balls tuck in the same time and the fourth one tuck in the same time. You make a vortex very, very strong in this area. And without friction. You make a reactor very
Yeah, maybe with the right design, but it'd be pretty tough to have one, because they're in different orientations. The ball will tend to do funny things with the one motor, I think. But it's interesting. It's an interesting idea to create.
I know. There are one more idea. 1 minute, please.
Like it might work better with using a coil underneath, or a small coil underneath each sphere. Actually, could control each sphere that way, and then you have no rotating parts at all.
You see, when you put the reactor in this way, you have double ball with a little magnet inside, and you make tuck in the same time with the magnet outside of the motor. This reaction is very, very strong. What I thinking? You have every material you have. I have nothing, but I have an idea. Make it, and you have. You can tell me a result. I think it can work very bad. The best way. You see, no friction with a little ball.
Well, it's an idea. It could be tried. Yep.
Yeah, I hope you try, and you can have a result, good result. Try it. And the second one, this is only a half what I have to show you, because these 3 reactors here, and the upside is 1. If you make the same thing, I do something like this, you will see. You know, you have 3 reactors and the upside, and you 3 reactors at the downside. You make this one, he make the vortex very, very, very strong. This is, you know why I have this idea? Because before I know the plasma, I have studied about a human. A human, now I present a human for you. You see, this is a push of the right hand, left hand, and the right hand. We have 3 steps of push. when you take a push of the hand. With that three position of push, I put them on the round. The same thing, you see.
Okay, is this standard Chinese medicine? Is this?
Yeah, it's Chinese medicine. Yeah.
Okay, thank you.
No.
Yeah, keep make sure you explain in detail because we want everybody to understand.
You know, if I explain with detail.
Okay, not too much detail. Not too much detail. Yes. Okay, carry on.
I show you only.
Okay, very good. Thank you.
How they work only.
Right. Okay, great. We can get more details on it if we wish. Different people.
Detail after.
We'll ask you a question if needed. Right. Go ahead.
Yeah, go ahead. Yeah. Now. You see, I explain this one first. This one is when you take a push of someone, you can know he's sick or not sick. This is traditional Chinese traditional medicine. They found this one, and before the Chinese tradition, they have only 5 elements. 5 elements is the. This is a. I show you this. This is a fire. I make a red one. This is a soil. This is a metal. This is a water. I make blue because water is blue. This is a mustard or thunder. I make it a pink because the pink is a mix of fire and water. And after we have a wood. But in the Chinese medicine, before they haven't, excuse me. They haven't this one. They only have 5 elements. Until now, they have 5 elements. And this one too, I put them on this side because when we have this this picture, I show you the fire. When the fire is the creation of the universe is a ball of a sphere of fire. We have a fire. You see, when this ball become cooler and cooler, they become soil. You see. And after the soil, with the reaction of the fire, the soil get the metal. And when we have metal, we begin to have water. And after have water, we have a tree, like traditional, they said. But before to have tree, we have something in the middle. Is this one. You see? This one is in the middle. But this one, the Chinese medicine cannot resolve, cannot explain what is this. But now I can explain is this one. This one is the 1 minute. I have sorry. It's the amino acid. Amino acid is the middle step become from the water to the tree. Because the amino acid, they begin to, the first life is the amino acid, and they become the work I have in my head, but
well, it becomes more it becomes a matter level, the 3D from the 2D, sort of two-dimensional.
It is smaller, but to amino acids they add together, they begin to have a what?
Substance, have materiality, have
it's something
have form.
It's enzyme.
Okay.
Enzyme. Yeah. Enzyme. They get together, they make a chain. Is aden. The beginning of the aden is the nucleus. You see, with the nucleus, they become to have a tree. Before to have trees, they have a monocellular, a bicellular, and after they become a tree. You see?
The DNA, is that what you're looking for? Guy's suggestion?
The DNA, the chain of DNA, make you have a nucleus. Because a monocellular have a nucleus and the outside, a plasma outside and the nucleus. A nucleus is made of enzyme. But you know, until now, no geology can explain why the fire make a soil and the soil make a metal. No one geology can explain. Now I explain for you. The fire is the ball of fire is come from hydrogen, like a sun. You see, when the sun become cooler and cooler, like the earth now, we have a soil. But what is a soil? A soil is the composition of the oxide metal. You know, it's oxide metal because the first one is hydrogen come to the from the universe, and when they cold, they have oxide metal. Is oxygen become at the same time when they become cool. And when the fire, you hit the soil with the fire, you have a metal. When you have a metal, you take out the oxygen. The oxygen with hydrogen become the water. You see, when you have a metal, the water become in the earth. The geology can never explain this way until now. I read too much the geology book, but they cannot explain. When the water have, we have the same time nitrogen, phosphorus, and some of metal, some of alkaloid. And with this one, we become the first, with nitrogen, we have the first amino acid. You see, the amino acid come when you have water in the earth. And after, with the amino acid becomes the the work I always forget. Yeah.
The DNA?
The DNA, yeah, the DNA, and the DNA becomes they have the first cellular in the world, and then they are double cellular, and they come the tree and everything, and after we have the man on the earth. This is the cycle of the formation of the universe. You see, this is come from Yinki. You know Yinki? Yinki is this one. Before become the fire of the red sphere, they divide in two parts. They have yin and yang, and after they divide on four things is yin yin yang yin, and yin yin. Voila. And after they have hexagram. The first hexagram become, when the first hexagram become, we have 6 elements with the this one is, they say, the sky and the earth. The sky and the earth, they produce 6 elements. But before, the Chinese medicine have only 5 elements, because they don't know the 6th one, because the 6th one, they cannot be identified only. And until now, when we have 6 elements, we can explain the creation of the universe, step by step. Yeah.
Can you explain that the purple one on that's called thunder moisture? Why is it thunder and moisture? Explain.
Yeah.
What other words can you use, or can you give an example of that?
Yeah. For example, you know, in the science, they have made experience. They put the water with the gas only. When they put the water with the gas and the soil, and they have only clean soil, clean water, and clean gas. When they put the potential in the bowl, they see the first combination of the amino acid. Why? With the thunder, is the act of the two potential make amino acid. But the Chinese, they know only, they put the name is thunder only. But they don't know when the thunder come, they put the potential and the amino acid become on the earth. The first amino acid. But I say,
okay, you're saying you're actually talking about lightning, I think. Not thunder. Thunder is the sound. Thunder is the sound from lightning. So you're talking about the lightning activating amino acids as for the start of life. I see.
I respect.
So that's kind of like plasma, though, right? That's
just first plasma.
Lightning is a form of plasma.
It's a plasma. They make the first amino acid. Yes.
Right. Okay. Got it. That makes sense.
Then after.
And you're saying that's what's missing in the normal understanding. Well, how does the fire?
Fire.
How does fire transform? Can you explain that process? How does it get from fire to it goes to soil, right?
Yeah.
Okay, explain how that works.
Now they work like a sun. The sun they become before the temperature is very high. When the temperature become lower, the soil go out like the earth. The first time the earth we have a soil, but this soil is composing of the oxide metal.
Guy has something to say about that. That's interesting. Would you just say?
You know.
Wait a minute. Let Guy say something here first. That's interesting.
What would you call that? Solar dust?
Yes, is this one the yellow one? Yeah,
you've heard of that phrase, solar dust? Do you know what solar dust is? The space dust that's out in space. In a way, maybe that's true because it goes through
cooling,
the fire and flame, and then cooling process, and it becomes dust, which is like soil.
Dust or soil is the same thing.
Yeah,
same thing. Okay, good.
Yep, space dust.
You know, this one. We have about 6,000 years before. 6,000 years before. You know why we have? There's someone outside of our earth teach us. But
well, they would certainly know about space dust. So.
Now. Until now, I can explain to you. But before, they have only 5 elements. But they explain differently what I say to you. This is very interesting. With this one, you see, this part is metal. Metal. And this part is energy. Because fire is energy. Metal is the energy, and the moisture is the energy. Because with this energy, they make matter. With this matter, we have a soil is matter, wood is matter, and the water is matter. You see, we divide in two parts. But this one, you see, when you have a fire, the fire make the soil, and the soil mix metal, make water, and water make a mix moisture, and moisture make wood, and as the wood burn become fire. You see, the cycle is very interesting. But if I put this cycle in this part, in the round one, you see, the fire make soil with make the metal make a water make a moisture make a wood, and wood make a fire. You have a cycle with a revolution of the matter on the cycle.
Okay, interesting. How would nanomaterials and GANs fit into the cycle? Where are they in the?
But now you see, before I say this part is matter. This is part energy. You see, if I divide these two in two parts. Yeah, this one axis. This is the matter. The matter is made by the on the planet, in the earth. These three become have, because the water, when the planet formation of the earth, we have water. The water make the tree, and the tree after burning becomes soil. This is the matter of the earth. And now I make energy. I make energy, matter is energy. Energy is a fire. Fire, he make a metal, but the metal really is not a metal, because they call the metal, I take the same name, but this is all of the metal. They have a carbon, nitrogen, phosphor, manganese, everything. And with this one, they become the first monster is the amino acid. You see, this is a energy come from the fire, and the metal, they make amino acid. And the enzyme and the monocellular and the fish and the animal, and after the man become from amino acid. You see, if you look at this one, you see like your reactor. You see, reactor like this one.
Or like the CO2 kit.
Yeah, this is inside bowl. This is outside bowl. This is inside bowl. This is outside bowl. And this is inside bowl. It is outside bowl in three parts. And the universe is a big bowl. You see, look like what I say. When I looking at the reactor, I thinking about that one first, and after I say about matter, the same thing. With matter is same thing. They have three reactors with the planet. Why? Before I say to you, we have two reactors, one in the upside and one in the outside, in above. Now, one in the up and one in the downside. You see, if you can put two reactors in this way, it makes the plasma vortex very, very strong. Why I want to say to you, I cannot do, but I have ideas. I give you ideas, and you make experience. It's faster. If I make this experience, I take 1 year, 2 years, or 5 years. But you can make only 3 weeks to make it, and you have a result. You have your answer at once. I hope you can make this one, and you have a good way to make a reactor faster and easier. Why I want to present to you today.
Okay, well, thanks for that challenge, and it'll be an inspiration for many of us, I'm sure, that are playing with these ideas.
Yeah.
Whether yeah, it's entirely possible we could put this experiment together.
Yeah.
This is what we need to do in this group, actually, is to get suggestions for new experiments, and then have the actual lab space to be able to set it up, show it in the next class, the next time we have a gathering here, and be able to implement it right away. I haven't been able to do that lately because I've been busy with other things in my life, but that is, I think, about to change in a major way. So there should be time and will be time for these kinds of experiments, and this is exactly the kinds of suggestions that would be fun to play with and educational. So yeah, thank you.
One thing I want to say to you, with this kind of what I present for you, this is yin and this is yang. If I can equal yin and yang, any disease can be dwarfed. I can help any disease with equal yin and yang in the same time. That's why I have made for too much people. This is the best way for the health. I want to say to Mr. Keshe, if he can push this way for the health because I'm not doctor. I cannot. I make inside the explication of this way. But if he want, I explain everything to equal yin and yang to make for the human health. I have to make, because this is, I say to you, is the best way, because we have three jewel of the human. What is the three jewel? The first is the soul of the man. The second one is equal the yin and yang. And the third one is the matter of the body. The matter of the body is Mr. Keshe is doing now, because the matter is equal, we have no disease. If yin and yang we can equal, we have no disease. And third one, if our soul can equal, we have no disease too. It's three way. In our tradition, we say, if we have these three jewels, we have no disease. But Mr. Keshe say for the third one, but the first one is a soul. But the last time, Mr. Keshe said, the man who understands the soul, the master of the soul, the soul master is Buddha. Mr. Keshe said this one, because if you want to equal the soul, you have to learn from Buddha. If you want to equal the yin and yang, you have to learn this one, the sixth energy. If you want to equal the metal, you have to learn from Mr. Keshe. Thank you for your listening.
Thank you. It's very interesting. It's a whole different perspective than our ordinary Western world, let's say. But it's we need to work more and more to match up, because this is something, like you're saying, that's been essentially used for thousands of years, and may have come from a very high source to start with. I mean, it's possible that they knew that matter comes from the plasma of stars, basically, and so on, from very basic ideas like that, rather than just the things on the planet, if you look at it more universally. then it becomes more important all of a sudden. Anything else you want to speak about that? And I think we can also see if anybody has any questions. Perhaps there is some questions here.
Someone want have a question. I try to answer.
Okay.
As possible. I'm not a doctor, but I try to answer. Some question, please.
Yes, please give a question so we can continue stimulating this conversation a bit here.
Can you explain the numbers on your chart?
Number of chart. Yeah, you see, this is for me. This number I put 1 year to make this. You see, now I explain with the round one is easier to see. No, this one. Yeah, this one. You see, I take a fire with the red color, a soil with the because your soil is yellow one, and the metal I take a silver color of the silver is a gray one. The water is blue, is naturally. And the master is the water and the fire have a master.
Excuse me, can you move it so that we don't have mountain metal and thunder moisture beside there? Because I thought that's what they were talking about for those two. Can you just move it a bit, or maybe it's hard to do, I guess, to move your screen over that way. I'll just move my screen for live stream so they can't see that.
No, now I explain only for the color. I play with the color. You know, I play only with the color.
Yeah, the color is great. I like the color coding. That helps a lot.
I make a color coding because the fire is the red one, the soil is the yellow one.
Right, it's just the way your picture was on the screen. It showed mountain metal beside the yellow one and thunder moisture beside the gray one. So it was kind of misleading there. That's all I'm saying. Before, it's okay. Yeah.
Before I have to explain the outside before, and I enter to the number because the outside is the original. The first one we have to need to know, and the element of each one, you see, you have six color, and the wood is I take a color of the leaf is a green one. It's for wood.
Mm-hmm. So what about the numbers? Tell us more about the numbers. I don't understand how the numbers, like at the top, you have 1, 2, 3, 4, 5 in different colors.
Yeah, 1, 2, 3, 4, 5. This one is a way. What is a is a position of the point of acupuncture on our body. The first one, the second one, the third one, the fourth one, the fifth one. Because 1 minute, I want to show you acupuncture. 1 minute. This one. You see, this is the point of acupuncture on the body. The first one, the second one, the third one, the fourth one, and the fifth one. This is the order of the point of acupuncture on the body only.
Okay, I see.
You see.
Thank you. That's more. That clarifies that much better. I see how the color combinations help a lot too.
Yeah, you see now the combination of the color and this is we have 12 line, and we have 6 color. We have yin and yang inside everything. But this one, if I explain, I have to take a mouse to explain for you. But now I return with this one. This one is only the number of the position of the point, acupuncture point on the body only. It's okay. Now I explain.
Yeah, that makes sense. Makes some sense now. Yes.
Yeah.
Not sure about now the inner ones, I guess. Eh?
Yeah. Now after this one, you see the number have a color. You know why the number have a color? Because they have to respect the order of the cycle. Because before I say, the fire make a soil, the soil make a metal make a water, water makes a monster make a wood. You see in the fire, the first element is the soil. You see, fire go to the soil. You see, the fire first for the soil. The second one is the metal. The third one is the water. The fourth one is the monster, and the fifth one is the wood. You see, inside of this one,
yeah,
they have respect the cycle of the revolution.
And is that the way you would treat for that, say, ailment or for that excess? Yeah. Is in that order of those points? So, for example, in the number 3 time in the top one there.
Yeah.
Whoops, I didn't mean to do that. It is in blue, so you would treat the number 3 spot on the blue meridian.
Yeah.
Is that correct? Is that the way you would? Is that the way this works?
Because if I explain this one, I take 1 or 2 weeks to explain.
Oh, okay, never mind. Let's not get into that. It's just my mind wandering about that anyway.
You see the order of the number and the color of the number. They have respect the cycle, because the cycle is a red to yellow, yellow to gray.
Yeah, yeah. It makes sense. Yeah, it makes sense now. Sense.
They have to respect the cycle of the evolution. The evolution is come from fire to soil, soil to metal. Inside here, they have to respect the same cycle only. And this one, you see, the green. After green, they make a fire. You have the first fire, and after soil, after is metal and water and master. And this one too.
Okay, yeah, I can see that for each of them that way.
Yeah, it's very efficient. But you see, this is a matrix of the body. This is matrix. Why I say this is the first time I saw it. I working in it. I saw it, and when I put the color and I put the number, oof, I can resolve everything on the health of the human. I can balance the yin and yang to be equal. You see?
Yeah, I think I can understand that.
Yeah.
What's the H for? You have an H there in your diagram too.
H.
It's in all of them.
H. You see? You see? They have in this one. We have 2 sides of opposite. Fire is water is opposite. You see?
Yeah.
You see, fire and water is opposite. You put the fire on the water, they can match. The soil and the master too. You put the master on the soil, the master cannot work. and you put a moisture on the soil too. And the metal, you put the metal in the wood. Wood cannot grow up, and you put the wood on the metal, and the wood metal cannot work. They opposite each other. You see?
But what about the H? What is the H for?
Yeah, because they are opposite each other, we have to equal them. H is the thing for linking with because like this one, the H of the red one have to linking with the first one here to equal. The H is like something like ambassador. they put fire and water together, and this has have to link with the first one of the fire. If no, they two cannot linking each to other. The H is linking the opposite of the other. This H,
okay.
This one, this H, this one. And
well, it makes, I can see that the opposites are, the H orientates the same both ways. So you can tell which one is the partner. Yeah. Okay.
But you must think to learn with this one. I have to explain for 1 month everything.
Yeah. Right. Well, we need the short version for us tonight.
I know this is the first time you have see those things. I say
I've seen some similar diagrams and so on. But not this. No, this is...
not this one. Not this one.
Yeah, this is special.
Chinese traditional medicine don't know this one. I know, I say to you. This one just have reached on the earth only for 10 years, not too long. And I study and I make this one for the first time for 1 year. It's very new. This is very new for everybody. I know. But I want to explain for Keshe because I think he can get something better for Keshe. Hello. I stopped my my sharing.
Okay, we'll put the video back on, I guess.
Someone ask some question?
Yeah, let's see if there's any questions, and I'll put my video on here to fill in. Yeah. Oops. Bring this back. Okay, so, oops, let me get my audio on there. So is there any questions about that? How can, is there anything anyone wants to know, additional details, or that was quite nice. Hello, Thomas.
How are you? Hello, everyone.
Oh, there's two of you. I couldn't see you. Okay, there we are. Okay, good. Yeah.
Okay, hello, everyone. Wow, very nice presentation, very nice, interesting theoretical model. And to check this, I didn't get any question. I have one thing to show you guys. Maybe that's going to be helpful to realize this experiment. I think.
Okay. We also have.
Depends what you like to achieve, but it's kind of a lazy way to create reactors. Kind of lazy reactors. Wait a moment, I will show you a photo. How they look. That's only for kind of experimental purpose. Wait a moment. All right. that's the basically reactors. I mean, it doesn't look like typical reactors. Let me show you the photo the first. Okay, wait a moment. That's the electric, a little bit dusty. That's the electric cooler, the small cooler from the computer. Everyone knows these coolers. I just chopped the wings, take them out. As you see, just completely shave it, and these 4 mysterious dots, that's the gases with the beeswax. I mean, outside is the beeswax, inside is natural resin with the dry gases. I use from the medical purpose, I do kind of experiments with small reactors. This is the spinning reactor. They work for, I don't know, probably 10 months from now. That's the reason why it's extremely dusty. Sometimes I try to clean up them. And this is my one of the broken coils. I use them to provide power supply, because they suppose it should be plasma power supply. In a second, I will explain all this construction. And that's the photography, spinning reactors. That's the constructed reactor. The constructed reactor combine a few elements, and the most important are gases. I think this is a good idea to check, for example, this concept with this from the Chinese medicine, the fresh one. So that's your gas combination. That's your in my case, all the gases. This is the CO2 with the proportion 1, and zinc oxide with the proportion 3, something like that. If you get kind of measurement scale, is 1, 2, 3, 4. So this is my zinc oxide. This is my CO2. This kind of proportion. I mean, whatever you like to do, whatever you like to check, I always leave you free hands. Do whatever you like. And on the middle, I get different combination, because this is the gravitational. This is more like magnetic. This is more like gravitational. So this same combination, but with the more CO2 and the plus CO, but the dry gas, the black copper, just piece of the black copper dust, the gas from nano-coated layer. So that's the basic, that's my way to construct the story with the gases. The next thing, this is the piece of this isolation, because always get some kind of, I don't know, fraction, kind of resonance, and to stabilize the engine, make them quiet. I use something like that. I don't know, piece of rubber, gonna be fine. Whatever you got, something to isolate the vibration. And this is my black mirror. This is the nano-coated copper, and completely polished, highly polished, just like a mirror effect. And I use this copper to isolate the engine from gravitational part, which is everything outside. It's like basic isolation. So the last thing, this is the power supply. This is the DC 12 volts, normal average power supply, 12 volts, and if I could remember, that's the 50 milliamperes, something like that. If you get 1000 milliamperes, it will be absolutely fine. But the most important thing on this power supply is not typical power supply by straight DC. They go to the magnetic coil, and this magnetic coil turn everything to the plasma state. So this is not piece of any single electricity inside the circuit. This is always plasma, but behave like electricity, you know. And this is all the elements all together. And let's go through the next shots. Whoa. Okay, this is the way how I combine all together. This is the constructed the first element, the base, and after the base, reactor on the top, and spin up the reactor. This is, I get the engines with 2 different speeds. This is very typical from the computer motherboard. If you got plenty coolers like that, you will find plenty of them in your box, probably. The extra wiring is the regulation for the speed. So this is the slower version. The slower version is, as you see on the RPM meter, on the tachometer, 2,798. This is the faster speed, almost 6,500. I mean, no, something like that, 6,000. And this is the second one. Second one is always 3,000 and a half, something like that. Okay, that's the next thing. And this is like a lazy reactor. If you like to use them to check your ideas, a very, very quick way, and I made this reactor cost I don't know, maybe a few minutes. I mean, the only you need to be prepared. So you need dry gases. You need to make your own combination. You need to prepare BWOX and other components, whatever like to use. I use the extra because that's the last thing I think actually is important, because this is the story of the gases. This is the BWOX, but this is the combination BWOX and resin, the natural from the plants, because the resin combine CH3, and this is natural CH3. So as amino acids, because they always plus amino acids. So as brain is prepared to reach this signal, because this is the amino acids will come from plants. So we got all the filters inside us brain actually tune naturally to this type of amino acids. So your connection between the reactor gonna be better, and I think your sensation gonna be stronger. So that's the point. Just catch you by the amino acid, because when you get the resin, you get this. They come from the trees. So. And BWOX get another combination amino acids, also by CH3 mostly, but not only, because get CO2 and other gases. If you check what is inside BWOX, you're always going to be surprised how many things you got, and which more important, they got still again amino acids from natural environment. So as filter, which is as brain and as fields, is automatically tuned in through this field. So we suppose should get big easiness, huge easiness to reach the field and get some sensation. So that was the point. And the last thing, sorry, stretch the topic. And because if you like, just do nano-coating. How I do this nano-coating? Cut the cables, take the zip plastic bag, put to the big zip plastic bag, spray it by your solution, and left them on your window for, I don't know, or even in your garden for 2 days, 3 days. Don't dip it in a caustic cold, because this is the electric engine. Just spray it for outside and left. And if you're gonna left with a vapor condition for a few days, will be fine. After then, in a very delicate way, try wash up from the caustic. It's easy. It's painful, but it's time-consuming process. But it's possible. So it's not any big problems with this. But try to do this from the top. Remember, this is electric components. Don't go with the water inside. That's only one thing what you need to remember. So that's all the story with the small reactors. So that's maybe gonna be helpful for someone who like to check all these ideas in an experimental way, less theoretical, and if you like to match a few different ganses, because as you see, I build something like a star formation. So that's the one reactor. On other reactor, I get different combination. I get only 3 ganses like that. We have no any drop inside. So if you like to build reactors like that, if you like to build reactors like that, whatever you like. And remember the one thing, if you're gonna do proper, I mean, it's not made proper. If you're gonna spot from the side, you get something like that. It's not the perfect sphere, but if you're gonna do correctly, I was in a rush and a little bit impatient, and my sphere not that perfect. But if you're gonna drop 1 drop of hot wax or something like that, top of your engine carefully, you're gonna achieve the sphere. So that's your reactor, the most simple way, and the gases inside the gas condition. Okay, this is the dry gases. That's a different story. So, but for the experimental purpose, I think it's not that bad idea. So to make you free from many problems, technical problems. So if you didn't get this reactors from China, this spheres with this engine and stuff like that already prepared to do proper device, I mean, maybe this is the extra option. So I got something.
Thank you very much. It's certainly safer than most of the high-speed rotating spheres that might come apart or otherwise spray GANs all over the place and so on. This is all self-contained. Yeah. Other than, how about when the motor heats up? Some people complained about using hot glue, excuse me, hot glue on their motors like this, because when the motor heats up,
yes,
then it can melt the hot glue, and then your sphere can come shooting off. And
yeah,
especially
nightmare for many weeks.
Oh yeah, especially when the wings are cut on the motors. But of course, if you have a ping pong ball full of GANs, it's much heavier than what Thomas has shown here. It's very little resistance. That shouldn't. That motor should last forever. Rotating those.
Exactly, and the one thing, if you like to go, you see the 2 motors. I mean, if you like to build star formation, even I don't know 100 star formations, do it. This is so cheap version, and the field is quite. I didn't say strong. I mean, it's strong, but it depends of your gases, depends of other devices, depends of you know, all the environments, because they work with the conjunction with your maggraph and all the stuff. But according to Mr. Machran, for one of the latest teachings about the reactor with the zinc oxide, I think this is a very easy and very friendly solution how to achieve this point of the technology and build something like even 3, even 4 reactors. It's extremely quiet engines, really nice, handful and flexible to use and manage.
If you could actually show some kind of effect, you know, maybe with lab rats in a environment where they have regular fans and then they have fans with the GANs fans. And if you could show a benefit, imagine if you could convince a company that produces millions and millions of these fans, that if they can make them into GANs fans very cheaply, then they'll probably have more fans for their GAN fans and sell more of them, and we would get the GANs out into the world and everybody would live happily ever after.
Absolutely. Another idea, very interesting.
We could have plasma powered by plasma stickers on every computer.
Exactly. When you got, let's say, that's going to be my visualization of typical computer cooler. Let's say this is the motherboard circuit. This is the motherboard circuit. This is your PC or Apple, whatever. With Apple, it's more difficult. I mean, with PC, it's much more easier. Open and always top of your processor, you got your cooler, basically, and this cooler always work when you work on your PC. So do a small experiment, and if you like it, just do something like a 3 drops of dry gases with, for example, zinc oxide or whatever you like, and observe what's going to happen with your computer. They're going to work better or not. I think they're going to work better. I got few experiments behind me. I get different cooler now. No any gases, but I get like 2 reactors and quite strong field around. So my computer is already inside the field. I don't need to do this extra field, extra things. But you know, the variety of way to use an application is so huge and it's so easy, because for me is actually the most important for now. Create something like kind of gently support for all this medical system. How to actually give you the most simple tool to create something like a. It's difficult to compare to big medical system with, you know, big walls and stuff like that, with the 32 coils and stuff like, you know, the big organized things. But this is a really nice solution, because when you got 4 engines, so you need to do only one thing. You need to only 1, 2, 3. Okay, let's say 1, 2, 3, 4. Oops. Oops. Sorry about that. Okay, I'm here back. Okay, you need only 4 reactors like that. And if you got possibility to spin this reactor, this is idea from star formation, nothing new, nothing, no any revolution. I just repeat after Mr. Makram. That's all. The 3 reactors forming the one field, the other outstanding engine go to the different directions. So if you get the problem, because mostly all the coolers work only with the one direction. If you get a problem like that, so use the different gases combination. So either. Okay, one option is do with the speed and with the direction for your speed. The other option is by gases.
You could turn the unit upside down, and it would in effect be turning the opposite direction.
Exactly, that's another option. And acidic alkalic, but with this option I was trying, you know, with this. I think we will. I think I know what you're talking about. I tried this kind of construction top of the engine with the next one, with this opposite direction to the field between, but I was refused. This was really noisy, shaking. I was massive problem with how to stabilize all this construction. So I was refused for now, because I got something more interesting, guys. Solid state for now. I mean, really interesting way of build MAGRAPH. This is my last kind of, let's say, invention, this discovery, and this is more interesting for me than actually trying much, you know, vibrating engines, electric engines. But this solution I think is good for medical purpose, because the CO2 plus that was Mr. Mahan mentioned, guns from zinc oxide, and just spin the reactor to the average speed 2000 RPM, and everything inside. This is, if you're gonna do 3 dots, you get fantastic fields. I think if you like to speed up the field, do some kind of experiments with these 3 dots, you should start think about the proportion inside the gases. So if I say that's going to be color from the CO2, oops, sorry, that's going to be color from the CO2, and that's going to be color for example, zinc oxide. So combination, 2 zinc oxide, 3 zinc oxide, 1 zinc oxide. So CO2, 2 CO2, 3 CO2, 1 CO2, and this kind of proportion, whatever you like. And now you got also different fields between the dots, and they try always find each other and stabilize self. So they will create, you know, different fields and extra extra spin inside the field. I mean, it's always measure of hundreds of thousands of experiments, or maybe less. But it's easy to do. Bunch of coolers for old PC. Go to the computer service somewhere in your area. You probably know some places like that. Guys probably got boxes of old dusty coolers, and they always drop this through the rubbish. Always. They never know what to do with all the stuff, because they need to collect them, you know, put to this kind of collecting point for the special rubbish, pay money for these things, and etc. etc. So the better option is just ask the guys. Maybe they got some extra rubbish. They got plenty like that. I got from my friend actually a service like that. So plenty of them. My problem is I didn't get enough space to actually hold all this dusty coolers from the PC in my place. So I always use only like 2, maybe 3. And the one thing on the end and the conclusion, because last time when I actually try to set up a big installation using the Reactor, so the installation was like 1 to 3 or something like that. It was 9 engines, also the engines like this. Yeah, that's what actually Rick mentioned. That's the story with the reverse, the 1 engine on the top or 2 engines on the top and others from the bottom. So like 2 different directions. And the field was amazing, and extraordinary observation. All the stuff was actually Mr. Mahan show with the reactors, how they try and find self-position. That was amazing, because when I start to speed up the reactors, they just start change the position. They automatically start align to the field, and that was actually dynamic construction. For example, the different gases with this engine, they make them travel around very slowly, but by all night they travel around. Those one go this way, or you know, was bunch of movement between the reactors. I was hold like that on the piece of rubber, something like that, and keep them reasonable quiet. And that was quite extraordinary observation, and you see which type of fields behave which way. So this is my way to do this kind of experiments. So that's my conclusions. And I use these reactors on a daily basis, bottom of the medical system. They work fantastic. I think this is a good opportunity for everyone who has some kind of health issue and like to go to the stronger field. Just do something like that for yourself. Not take, I know, a few minutes. If you get all those dry guns and stuff, because that's the starting point. And just use any piece of wax, anything like that. The B-wax is actually the best, because that's true with the amino acids. You match amino acids to yourself, through yourself. So that's only one issue, and you got it.
Pretty cool. Thank you, Thomas. Any questions for Thomas? That was it's good alternate way to use these fans, which have been recommended by Mr. Keshe on many occasions, to just use a simple computer fan and put a ping pong ball on it, and away you go, which is part of our original ideas in the plasma reactor group a long time ago.
Exactly.
But this simplifies it and makes it safer, easier, better in a way, and who knows whether it may not be size that matters in terms of you might not need big GANs balls to be successful. It might be the small ones like this could work very well. Like you can see how it would produce a pulse, for example, with
that's true.
With the 3 orientation. If there were 3 magnets, you would get a magnetic field pulsing, an oscillating magnetic field coming off of it. Whereas if it was only one magnet in the center, rotating on its axis, you wouldn't necessarily get any pulsating field coming off of it, because the magnetic field doesn't actually rotate in that way.
I've got a very, very funny situation with or that's probably 5 or 4 reactors, something like that. And they start, because, okay, I'm not that precisely with this proportion between the dots, and was actually a big experiment. I was actually packed everything was possible to the 3 of them, and check what's gonna happen with some guns, silver and stuff like that. And the reactors was completely unstable. And when you put your hand top of reactors or between the reactors, you feel it, something like kind of shaking feel, like vibration, very, very strong vibration inside in the earth, something like that. But was not the wind, was field vibration, and that was instability between the reactors. They just try match, they can match, they actually create this kind of feedback. So I think it's huge that we have to do a lot of experiments. I got one. If you get a few minutes more, I got one thing more. I think the quite interesting option for everyone who actually build the magraphs. But if someone got any question about the reactors.
Going once, going twice. Let me just check the, Douglas says, Thomas is a great idea.
Thank you, sir.
And someone else likes the name GANS fans, Rick.
Yeah.
So someone else mentions there's glue that could stand the heat easily, but as you mentioned, Thomas, this is more, the beeswax is more amino acid friendly, you might say.
Exactly. Now I'm gonna do experiments soon, because I already middle of the way preparing the guns from calcium, because that's my own health issues with my bones and stuff like that. I'm gonna turn myself to the guinea pig, and so let's see what's gonna happen with my bones and this guns made from with the calcium, with the original calcium from the chicken bones and the pig's bones, because the combination of amino acids. Because, you know, all this physical part is only physical parts. This is only the way how we extract the field. The most important is the combination of this field. So if you're gonna go with the hot glue, I think you're gonna shut down your field on a 50% easily, even of the 80%, because because the hot glue is also like a magnetic magnets. If everyone do these experiments with magraph and the capacitors with the hot glue and something like a 2000 watts after next day, then perfectly know what's actually gonna happen. Everything gonna melt, because the hot glue mostly is the most popular hot glue. They got carbon bonding. This is the CO2, but this is the monomagnets, and they behave like a holder. They just keep all this interaction inside. So we got piece of magnets top of the other magnets, and they between the very heavy interactions. So I think they're gonna be fantastic field, but between the electric engine and the hot glue, not especially between me and the ganses. That's my point of view about the materials. The best way, if you like to go to all this health aspects, remember about your amino acids. This is your gate through the system. This is how we match all this information, amino acids. So we use them, use the natural substances with the natural amino acids, because naturally us brain is tuned to this amino acid. We're born with this amino acid. That's us environment. It's not the synthetic reality. It's not the plastic from I don't know, from one of the corporations who, you know, patented synthetics. No, nothing like that. They suppose it should be the most way, the natural substance. Even the clay, the natural clay, if you got kind of sticky, muddy clay with the ganses, this is the perfect solution. The people
what some cultures would use would be the sap from trees as well.
For
which
example,
is
yeah,
quite liquid and sticky to start with, and then it dries up as a hard resin that can actually hold something.
this is actually a perfect option. So, because they're gonna keep sort of liquid condition for the gases, which is another important part, because the liquid condition creates the different spectrum inside the field. The gradient looks a little bit different. The gaps between the magnetic and the gravitational field forming with the different distances. So you get little bit different environment. Same, but a little bit different. And this is the question always about same thing. How fast we're gonna tune with the field and how slow. The best option, go fast. Especially with sort of small reactors. Do you imagine yourself, you're just sitting on a chair and, for example, you got problem in your back. Only one thing what you need, maybe some kind of small plasma unit with one coil and 12 volts current supply connected through the small cooler bottom of your chair, and a few sessions like that, and you don't even notice it, because I mean you watch something in front of your eyes, not something what's stay bottom of your chair, and you're gonna easily forget what's actually happened after a few days. Wow, my back is in normal state. I didn't get any pain, anything like that. So that's sort of kind of way to use this kind of reactors, because they forming the stream on the top. I mean, depends how you're gonna build this stuff, because if you go with the dot on the middle with the heavy gravitational part, I use that's what I mentioned before, the GaNs from copper. You create something like a field on the top, and this is your reactor. So something like that. Yeah, this famous shape, and that's how they work. So, but I got the version solid state, gentlemen. The quite interesting version of solid state. The same behavior, because this is only the way to translate. How to explain in English? This is only the way how to translate the situation, not actually, we don't need to go always technically the same way. It's a few different ways to achieve the fields and stuff like that. So I'm going to show you something more. This is my new maggraph. I'm really proud of this machine because the field is extraordinary. It's just giant. It's twice times bigger. I never saw something like that for any maggraph. I was checked the field by this small electromagnetic meter, and so no doubt twice times, even 3 times bigger than normally. But this is the normal maggraph. It looks a little bit different. The first impression is strange because they look like 4 coils, and that's the 4 coils. But this 3 coils is a maggraph system. Those one is a capacitor. An idea is quite simple, and you got your 3 coils and the 4 coil. So let's use the colors. That's your gravitational part. That's your magnetical part. So I got one thing more, which is single core, because I got sun inside and the ball inside, and inside the ball I got my nano-coated copper pipe, and everything is connected to this coil, something like that. I got my lovely antenna on the top. So I'm gonna explain you why I got all the small things in a sec. Okay, and this is this part of the system is connected to the let's say minus line. So the connections look like that. This is my plus. This is my in. This is my out with the plus, and this is my minus. Oops. Let's see, my in and my out from minus. So all the signal, electric signal, this is electric current. Let's say okay.
Hello?
Okay, I'm here.
Yeah,
So
we missed your last sentence there, Thomas.
Okay, this is the, because I'm connect everything to the AC. Okay, this is the AC plus. This is my AC plus. This is my AC minus. That's the way how I connect all the device. And going with the colors. So this is my plus. And this is my minus. I didn't get any capacitor. I mean, I get one diode, but don't care too much about this. That's my experiment. Is not a part of this. I mean, is a part of this construction, but it's not that important for now. Let's skip this element. The most important is actually the core inside. That's the. Oops, sorry about that. Sometimes my screen jumping. All right. Okay, I'm here, and this is my core. And that's all the secrets. So the signal the minus come here. I mean, come through this coil, speed up the signal, and the end is connect through the core inside the maggraph, and that's all the connection. And I go through the end. I got more photographs, and give me a second, I'm gonna show you on the photo. So, but the shortly explanation, the plus, as you see, the plus is connect, go here and go out here, that's all. And all the capacitor effects, that's what we normally do inside the capacitor, happen here, here, and here. This is my solution. And also another point is the way how I try build something like shielding around the maggraph to create environment. So let's think about the maggraph like as living fellow, living creatures. So everyone like to, you know, get self room, get self space and environment. So I was building environment for the maggraph. So I get, let's say, magnetic coil on the bottom and this sort of antenna on the top. So I get quite magnetic shielding around the maggraph. So I closing all the interaction, the gravitational interaction is based, not the closing, but it's more like a compression effect on the middle, and also I get compression effect on the field, on the magnetic field inside. The tube inside is hollow, so I got narrow space inside, and this is my gravitational peak, somewhere middle of the system. Not gonna be visible. Maybe I'm gonna go darker color, something like that. So that's the idea behind. Okay, I'm gonna show you guys the more photos, and they're gonna explain everything. This is very simple construction. This is like this is another version, something for lazy people. How to avoid fighting with the capacitors? Just make one coil more. Okay, that's from the top. As you see, the antenna is connected through the hollow gap inside the ball, inside the maggraph. So that's from the top. I use this idea with the star formation and mix it of gases. So that's mean this is the dry gases inside my kind of, let's say, synthetic shellac, and beeswax and resin and stuff like that. All these organic materials, mix it with the dry gases and in a star formation shape. And also they include the dry gases, and also I've got wet gases inside the ball. It was kind of tricky thing to inside and unlock them. Fortunately, I was winning this case. In the previous time I got a problem. I lost all the wet liquid gases from my ball, but this time I was winning. Yes, practitioner make master. And And this is the without the okay, because I got the glassy jar top of the maggraph. The one reason is I like to create the like a close environment for the maggraph. This is the one thing. Just check how they're gonna behave inside the box. Other thing, I do a lot of things in this room, and it's always a little bit dusty, and I try avoid the dust top of the maggraph. Just keep him clean. That was the idea. So that's we are the glass. As you see, the connection now. Yeah, now you see perfectly. You see?
Did you? Sorry, Thomas. Did you say it was a glass cover or polycarbonate or plastic?
That's the glass, and this is the specific glass, the lead gas, lead guns.
Lead gas. Glass. Lead glass. Yes. Leaded. Mm-hmm.
A little bit from the Beatles. So let it be lead glass. And worked fantastic. I mean, it's a really good idea because I spray them from the top, for example, with the liquid plasma, zinc oxide, with liquid plasma CO2. I like, do this kind of environment. So on the photo, you get all the connections straight. So that's us in through the system, to the maggraph system. Remember, this is the in to the maggraph system. No any physical connection with the minus line. That's your plus, and plus traveling across the system, and they go out here. That's your, I mean, probably the black color, yeah. That's your out. As you see the red connections, that's in and out, south. Okay, that's the red wine, and what's happening with the blue wine? Blue line, that's with minus, go through this coil on the bottom. I get better shot. Wait a sec. All right. Oh, that's perfect. Okay, as you see, this is the one screen. That's my in. That's my out. And oh, wait a moment. That's my phone. Okay, it's fine. And this is my another in and out. This is only minus, and this is very, very nice to, I mean, I always find it's like something really comfortable, really nice to do, and quite interesting effect. The most important thing is easy to do. Maybe the most important solution lay in a country of laziness. This is the best motivation sometimes for finding the most simple solution. Maybe that was my way. But this is the one thing with this core. So as you see, this is the little bit liquid plasma inside my ball. Just one of, I don't know, this proportion of 1 of 9 or something like that, not even, something like that. I try be more symbolically precise than precisely, but something like that. This is the star formation. So, and all this core is connect through the minus line, but on the out. The signal, the idea behind is the signal who is actually spin on the coil, and is the most fast signal is on the end when left the coil. So the fastest signal go and spin up the field inside the ball. That's the concept behind. So that's the connection from the ball. But is one important thing with this construction I mentioned. So the trick is stops. Because this is that's the invisible trick. Armand mentioned this kind of way of thinking a few times. I like this way of thinking. I do a lot of experiment with this stuff, with the turning coils. This is, for example, a counter clockwise. This is clockwise. Two different directions. The capacitor go to the opposite direction. So you got fraction between the fields, strong fraction. Here and here. So because the antenna
friction you mean? Friction.
Yeah. Thank you. My English sounds horrible. Still horrible.
Your English is pretty good. There's just a few words here and there that's pretty good in general. Thank you.
Thank you, sir. And it's like a chamber inside, but this invisible chamber. I don't need to build physical limitation like walls and stuff like that. The small antenna on the top, try always find match field with the bottom outside, because this is the physical connection, and this is the unphysical connection. This is by field, because I got already opened the field. The one field create push for another, something like that. That's how behave this unit. And the most funny thing with the reductions, because okay, that's the theory, that's the technical aspects how to build this, but what's with the conclusion, because the device worked now for 1 week, something like that, and what's actually happened? The one thing, the size of field is huge. This is enormous size for maggraph construction. I mean, this kind of field, what you're able to measure with your kind of, this looks like a pen. It's your AC samplers, DC magneto-electric meter. It's something with the dot on the end. The lighting or sometimes do some sounds. So I use sometimes this kind of measurement instruments. So if you're gonna compare the normal maggraph with this construction, the normal maggraph is somewhere there, and this is this device is like sometimes 3 times bigger field. I mean, in my case, I mean, because remember the next thing that's the ganses, but this the other things I'm gonna skip for now, and the conclusion. I don't know, because I got other photography. I always stuck on one photography. I always get some more. Okay, that's from the bottom. You see the connection between the core and the bottom coil, which work like a capacitor. And that's from the side. You see perfectly the connection. The blue is the minus line, the red is the plus line. That's small diodes. We have no any paper inside. It's only GaNs form on inside the diodes. And this is the top. And this is the ball inside. As you see, elements of star formation and a level of liquid inside. So, and this is the device, fully packed in a box. So the conclusion was normally on this line, because I was connected, as you see, through the 2030 volts and standard hertz, which is normal line in UK, and load on this line is something like average. This is always plus minus, because I got my behind, so they're always jumping. But the load, the physical load, is between 100 and 140. Oops, was, and when I could a normal reduction with the magraphs on this line is I get some like 47 watts. That's the normal. I mean, reduction for the magraph system, because between this line was magraph, and after then go to the home power grid. It's like that. So a reduction from this was 47 watts. After when I connect the new magraphs, this system, I start to observe something like a reduction to the 33 watts, and quite nice jump, because always when you check your meters, you get something like a huge jump. Sometimes this is jump between, in this case was between 28 watts and 47. This is like a typical behavior from plasma environments on your meter. So the jump between this one was between 7 watts, was huge. So the jump here is like a average 50%. The jump between this is, wow, is not 50%, it's much more bigger. So, and the value of your reduction is bigger. So that's the behavior for now. For now, I got 22 watts, and load is now average 100 watts. And now when I look on my meter, I got 22 watts. So, and everything happened, yeah, I don't know, that was like 3 hours, something like that. So actually, that was first minutes when we connect the device and with my mates and we observe what's actually happened on the meter. The reaction was extremely strong, but other case, I get quite good fields at home, built by other magraphs. So that's actually helpful, helpful a little bit, but check by yourself. I mean, construction is extremely easy to do. I mean, if you get problem with your capacitors, how to do it, they're gonna hit the system or not, or whatever, If you worry about that, this is another option. I didn't check the machine on a bigger load yet, sorry. This is the nano coating on the middle of the process, more than. Anyway, back to this magraph system. Easy to build. Field is 3 or twice time bigger. Reduction is quite fast and faster than the normal system. I don't know how they're gonna behave on the bigger loads. By measurement, I was checked with just calculate the gap between. In theory, they're supposed to should hold 5,000 volts easily. So, but I didn't do this kind of experiment, of course, and I didn't put any heavy load yet. So experiment in front of me.
It'd be good to get. You have a temperature sensor, don't you?
Yeah, I've got it. That's the reason why.
It'd be good to check out the coil temperatures when you do the load tests on it.
Yeah, that's the next part of the experiment. And CO2 and zinc oxide and COO and CH3, very standard combination, but the standard combination is with extra something like that, small amount of other gases here, and this combination is different gases inside, different gases outside. Inside I got sugar, gas from sugar, because that's the extra carbon bound, and when I change the color, be visible. CO and CO2, and on the outside I got also CuO and zinc oxide and CH3 to open the magnetic fields, stretch the magnetic fields out, and extra. This is the carbon sugar on the inner coil. I just try to catch the interaction by the in the energy purpose. So extract the energy from the carbon, and that's actually all the secrets. No any specific gases. I just keep kind of simple things. Just use them gases when I use on the coils. So only inside the sun I got combination all these crazy varieties of gases, because that's the most heavy gravitational point. So this is my all gases.
Right.
With lead and stuff like that. You know, everyone gets some kind of crazy combination when you drop all your gases to the one box. I'd like use these things to the star formation. So that's all the secrets behind. So
Okay. Does anyone have any questions before we leave this topic? Lovely design, Thomas. Very, very nice. I love the glass covering there and so on. It's all very neat and tidy. Nice to see.
Kind of steampunk idea.
Yeah, it is. Yeah, I like that part. In fact, we've got pass me the thing there. I'll turn on my video now and
Victorian style, you know, it's match perfect London. It's kind of Victorian style here. So,
yeah, myself, let me just, well, I can't show my video right now with the screen share, but.
All right, I just stopped screen share.
All right, there we go. Yeah, I was just, I need to make sure everything's spotlighted. There we go.
Yeah.
I've got a same kind of deal here that I think you came up with this, didn't you?
Yeah, one of them.
And we have another one here. And there's even the possibility of putting one inside the other one. You know, something like that, for example, which could be a double. But in any case, yeah, looking forward to doing something interesting. This one's not glass, it's a type of plastic, probably acrylic, but it might be polycarbonate.
Easy to nanocoat. Should be easy.
Yeah, it's a winner for sure.
That's very interesting. It's gonna be fun.
It'd be it's a good container for a MagGrav unit. It's contains the coil with this size. I think that's probably 6-inch, and keeps the dust off, like you were saying. And you can see the innards without getting your fingers in, and possibly getting shocked and that sort of thing.
Yeah.
Yeah, nice.
The one thing to check is the propagation of the field, but that's only gonna be the valence electron, the free electrons. It's not the magnetic gravitational field, but only electrons manifestation. With this glass, when I got the stuff is absolutely fine, because I mean glass didn't behave like a filter. I mean they behave like a filter, but didn't stop the field. I was check the field without this glassy jar and with glassy jar, and always the same field. So it's really good stamp. This is a really nice thing. That's the success of speed glass. So
it's interesting.
If you're gonna nanocoat your jars, you're gonna probably achieve absolutely same effect, even probably better. Depends of mixture of your gases with the nanocoating, because if you're gonna put some extra fields to your jars, that's gonna be something. I got actually completely close way. I because this is the glass, it's already done. Nothing to do for me. Only spray it by gases from outside and optionally from inside. That's all. You got
right. Well, Shandor showed spraying of gases on his windows, which actually blocked the the cell tower communicator. The EMF. Yeah, exactly. So that's interesting. Okay, perhaps we should move along, and when I work toward wrapping things up here, it's been 4 hours now. But Zane has something he wanted to show. I wonder if you wanted to do that now, Zane?
Hello, what?
Zane, are you there?
Yes, I'm here.
Oh no, not Suzanne. Zane Lott. I'm talking to.
Oh, okay.
Okay, thanks. Hi, Zane.
Hello, can you hear me?
Yeah.
Okay, great. I got something I'd like to show y'all. Uh, a friend showed me a diagram of a electromagnetic induction, and I thought maybe I could convert it into like a plasmatic induction device, but I have to use my laptop. So let me um, see if I can show this to y'all. Can y'all see that?
Yeah. Uh-huh.
But I felt really compelled to build it. So
It's a little hard to hear your audio. I think it's, I'm not sure if it's me or just, I think maybe you're away from the microphone or something there.
I felt really compelled to build it. And once I started, I couldn't stop. And now I'm kind of stuck trying to create a switching circuit for it and then incorporate it into the MagRav unit and see if maybe if that will, you know, I could pull all the energy from the environment and put it into the MagRav and create a stronger field. But thanks for letting me share.
Okay, so what did you have in mind for a switch? What kind of switch do you think might work?
Well, I took a magnet and I got some nano-coated wire. Actually, it's a piece of ferrite. And let me see, it's kind of difficult to wrap due to just the way that the wire is, you know. So I was thinking, you know, wrapping it around this maybe twice would create a pulse, which would act like a switch, and then tying it into the device. And
Well, that's quite possible.
if that would do the trick. But, maybe sticking a neodymium magnet on each side of it, you know, to make it a little stronger. But I don't know, it's kind of up in the air right now, so we'll see what happens. But
well, toroids like that are very interesting in the way they can carry a current and so on. And if it was a superconducting toroid, then it would keep the current circulating in it virtually forever. And you can add or subtract from that rotating energy inside the toroid at any point you wish, basically. But they actually have ones now that you can add energy to them, and they just keep running. Basically, they just keep the energy stored up in there. Quite amazing. So you think of it plasmatically. A plasmatic toroid would be a perfect energy container, let's say.
yes, sir. Thank you.
But in that each toroid has its own frequency as well, so that would be part of it.
Another thing is, I thought that it would create a resonance as well.
Yeah,
you know?
yeah, I think you got some good thinking there.
Yes, yes. Thank you.
Okay, cool. Any comments on that, or anything to add or subtract or multiply? And is there anyone else with something to show or tell or discuss for today? Just looking at, let me see, there was a couple things here we have to deal with, I think. What's it?
Rick.
Hello.
This is Denny.
Hi, Danny.
Do you have time for me to ask Thomas a question about how he decided that set of coils would become a capacitor?
Yeah, that would be great. That's a good question.
All right, I'm still here. Okay.
So do you want to know what process he went through to get to that conclusion, or do you want to know more what the coil does as a capacitor itself? Like,
Well, I wanted first to know how he thought of it. What possessed him to think that that would be a capacitor, and then how he went about it to make it a capacitor. And then I like what you just said. What was it you said, Rick?
Yeah.
When?
Just now.
When?
Just now.
Okay. About it, whether you're asking about the process that he went through to get to the conclusion that it should be that shape and so on for the plasma capacitor, or the technical details about the capacitor itself, how it works and so on. Not sure if you want to know the story of the making of the capacitor,
well, let's start
or the
with
story of the capacitor itself.
Well, let's start with the easiest one. How did he come up? What kind of conclusions he had that this set of coils would become a capacitor, and then he can also tell us the workings of it.
Sure. Yeah, that sounds good.
All right, guys. It's going to be short drawing. And the first question, where it come from this idea? I mean, it's difficult to say where it come from, because it's something obvious for me. When you watch the magraphs, like 3 coils, and it's like, I don't know, difficult to explain. It's something when I see just immediately. It's like a natural conclusion for myself. I never imagined find some different idea in my head watching these coils. For example, look at the normal capacitor, because I think the trick is the way of thinking about dimensions, because normally we actually stick, because as environment, the type of education, we always stick with a very flat way of thinking. Seriously, it sounds crazy, flat way of thinking, but it is flat way of thinking with the 2D dimensions. So always when you see something like that, any schemats, anything like that, you just draw something, the capacitor line, go to the line, something like that. Everything must be organized in some kind of specific mathematical order or sort of things. So, but look at what we got in a different way. So, okay, let's go for a 2-dimensional story, but in a real environment. So this is us capacitor. This is the core inside, and this is the first stage of capacitor. So the first stage is connected with the rod. So the signal is actually generates the main signal come here, and they activate. It's like a pusher through the core. So they create first, let's say, resonance. So that's what's happening. We use this ideas in every single health unit. When you get the batteries for the health unit, that's a normal thing. And not only, if you're gonna check the Alex beats and a few other things from Foundation, you will find this solution in few cases. The idea is very basic. The line we got. Let's draw like a field. So we got the field, and you just spin up the field, over jump like that, and fraction between the fields, the inner field and the outer field, create the push to the inside. I don't know, this is the my explanation is clear, but if you're gonna imagine yourself everything like a spinning ball, nothing like a cables, just spinning ball. Normally we see capacitor from the side, but look at from inside, something like that, and you just spin. You got same move signal. This signal is faster. This one is slower. So the faster signal create different condition, and they push interaction through the core. So another interaction go out. So the other interaction, we get another part of us capacitor. So that's the next one, that's the next one, that's the next one. So I think many of us see now the MAGRAPH system. So this is the Caroline core. Caroline core is always double core. This is your first coil, magnetic. This is your gravitational coil. Your gravitational coil creates shielding for your core. So your core plus those coils, the gravitational coils, and you got Caroline core already. You middle of the capacitor. And so you need to actually secure the field. So that's your magnetic coils. So that's the way how you secure the field. Simple as that. So, and that's your capacitor. And it's one thing, more of goes with the capacitors, always you see kind of bridges, yeah? They connect parallel on you get in and out. So now take this capacitor once again. This one, this one, this one, this one, okay. And check the situation with the electricity supply. That's your minus, that's your minus, that's still your minus. And that's your plus, and that's your plus. It's simple. And now, this is the normal capacitor. Now you got it. That's your bridges, that's signal come in, can come out. Okay, I'm gonna drop some colors, a little more visible. And that's the secret behind. So, but that's from the side. But look at the different structure. Everyone knows it. Look at the plants. And you get plant. Go like that. And you see the different colors on the leaves and stuff like that. This is your field. That's a signature from different fields. The different color mean different type of field, different parameters. There's gonna be zinc oxide or whatever, CO2, anything. If you know the gases, you know the colors, and you watch the plants, you perfectly know what they got. And you see combination of the fields. And as you see in the plants, same story. You get your leaves, your root system, and you just need support the connection. And if you see closer in the plants, that's your heart in a plant. That's the place when plant generate the gases. That's the most stronger field of interaction, something like that. This is the place when you got the most stronger interaction. But to hold this interaction, you need all this way across the plant through the top. So the first thing is the root system. The root system, the bonding, the flow inside. So that's as first bonding. That's the root system. We actually use the current like a root system. But if you didn't get current, that's like, for example, in a medical system, that's your own field. So anyway, that's your info system, and that's your roots. And next thing is the rest of the plant, and the rest of the plant deal with the sun. And this is, let's say, soil. This is the earthy condition. So you get a few different types of fields. So you need to only create a holder from the one type of fields and a holder for other type of field. The one, the roots support all the system, because you get straight connection. This is like a us brain. Let's say this is the human brain, and this is your rest of body. See, this is all your nerve system come from the brain, and it's the same thing. You see that it's like a fluctuation of plasma field. You see the this sort of reaction. So if I'm gonna hold this, I'm gonna hold reaction on the top, same like a plant. The hold reaction on the bottom and also open reaction on the top. So that's where I come from. This idea is quite simple. I'm just normal basic observation in my garden, nothing more, nothing less. So it's basically the reconstruction from the plants. So that's your capacitor. And now if you're gonna turn all this capacitor, when I draw here, this one, on a 90-degree, what you got? You got your McGrath system with your coil. And the one good thing, the coil, because the coils get same size like other coils, they match perfectly by field. So that was the first conclusion. Okay, I need to do a system who actually is able to balance itself. So how am I gonna build the capacitors? The capacitors suppose should be part of the all the structure. Nothing. It's not the outside. It's not like another element, like outsider. No. They should be. This element should be part of all the whole structure. So that's the point. The plants, when you look at the plants grow like a one unit. It's not a situation when the roots is 5 meters from left, the plants grow 4 meters from the right, and other parts of the plants are just spread across the fields with the pieces. No, all the pieces are together. And if you look at the construction for every single plant, you see the capacitor, the battery capacitor, all this interaction, they are held inside to not exactly hold inside, always like a hollow. There always is a Caroline core. It's like a nature, natural form from the nature. So the only one thing is just secure the interaction to actually go always same way. It's like a Caroline core, like a single, like a double core reactor. So I need the one interaction and the second interaction. So and after then, I need to recreate the same shielding with the next type of interaction. So this is like Earth and the atmosphere. So the next interaction and next. So that's the way how I build the interaction, the strong field, because the first things I got interactions from the capacitor, but inside another I got interaction from the McGrath. They amplify all the system inside, because the same like a plant, they amplified all the system. And so I think this is the most easy explanation. I don't know, it's clean enough. So probably a little bit messy with this explanation. Guys, if you some problem with my logic or some understanding, just give me a question.
Well, Denny, did you get an answer to your question?
Yeah, I understand how he came about it. Now and also why it works for him as a capacitor. Now, when he connects the negative to the capacitor, it comes into the gravitational coil of the inside coil. How does he connect the wires of that capacitor?
It's not no any physical connection. I will back to the photography, because there's no any physical connection like like inside the capacitors. I mean, inside the capacitor you didn't get also any physical connection. There's no any, but you get.
We're not seeing your screen share.
Okay, wait a moment. All right, we got it. Okay.
Thank you.
All right. So let's go straight to the right photo. And okay, that's the one. And as you see, there's no any physical connection between the coils. They only work with the same field. So no any crossing signal, something like this. Correctly with English, something like a cross signal. But normally you get something like the field outside and your core, and the core is for example, a minus, the field outside is a plus. So that's how work normal capacitor. So, and the gap between is quite narrow. And inside this gap, you get open fields by gases and plasma and stuff like that. And this open field make electron for not only electrons, but electrons flying in Earth. So sometimes the capacity of this gap is too small to hold all this open electrons, and we see the electron, but this is actually field from outside, and this is the way how fields interact with each other. Partially, they manifest itself like electrons, but this is only a small fraction of all the situation. So, to avoid every kind of physical connection, anything like that, we actually, idea was push everything through the plasma. So the gap between two coils, between the system, this is the McGrath system, this is the capacitor, is nothing, it's just nothing. Same like inside, you got your coils and you got core inside. That's all, and nothing.
May I stop you just for a moment? That antenna is connected to the magnetical wire of the outside coil.
Yeah, that's the out from the capacitor. Exactly. When you get out from the coil, one part of the core, you just connect them through the core, another part go to the electric grid. That's all secret. I mean, if you like to try in a different way, for example, put the first signal through the coil and after then go through the first go to the core and after then go to the coil. I chose a different option. In my case, the signal, okay, let's draw like that. The first signal go to the first step, go to the coil, and the next step, the second one, go through the core, and from core you get the magnetic gravitational condition, which they open in signal from the stacker. Another part go to electric grid system, something like that. And this signal is something like let's say loop. See, this is a looping situation. I mean, they work. Oh, sorry, because I was they go different direction. The direction is here because the McGrath's field go there, and this field inside, because it's also bounded in opposite way, they go in opposite way. So I got quite strong fraction. That's the reason why I got strong field, because the fields happen in Earth. It's not a physical on the coils, on the combination between the capacitors and cables and stuff like that. Everything happened inside here and here around the core. So it seems to be extremely safe from big load. I didn't check yet. That's what I'm waiting for. It's fresh system. I just now accommodate the system to the new environment. It takes me next few days, and after when everything gonna be fine, because always after when you put all the stuff together, you always disturb the nano layer. Always. It's almost impossible to hold them in a perfect condition. So I need extra time to rebuild all this nano layer on the top of the coils, and after a week, 2 weeks should be fine, and I'm ready to in this week slightly slowly start the experiment with big load and checking what's going to happen with the field. For now is impressive. I mean, no any heating, no any problems like that. The maximum was 500 watts for the McGrath for now load, and no any problems at all. It worked perfect. So everything is in front of us. We do some experiments and check, and so maybe this is kind of easy extra solution to build really, I mean, kind of nice way designed capacitor through all the system. because by definition they will match perfectly because this is the same coil.
And the capacitor coil is a different turn when you make the coil.
Yeah,
so when you make your magravs, I don't know which way you turn yours, whether it's.
I mean, it doesn't matter. I mean,
but your capacitor is a different turn.
Yeah, exactly. That direction, let's say. But this is the schematic. I mean, I didn't remember which side is mine. I mean, they're always same. This one go this direction, and this will go this one go this direction. The opposite, always opposite direction. Because that was my kind of way of thinking. Okay, we got the full signal, and we got the load. This is the, let's see, a smart graph system. I would go like that. I would draw the color. In the moment, make everything clean. All right, and this is the hot wine. This is as plus. This is the minus. This is the graph. So seems to be signal. We actually push the signal through the load like that. This is the direction for the plasma. The plasma basically suck all this AC current and transform everything through the plasma condition. I will draw like that, and this this plasma condition, you get those direction, go through the devices. So inside the devices, you got also electrical circuit, and partially electricity is on the way back through the system, but everything was back to the system. This is the plasma state. So you get the plasma state with some, let's say, this direction going there. And when you back through the system, you just reverse the direction to the opposite side. So you get the fraction between the incoming field and incoming field and outgoing fields. So that's the reason why is that strong, because this is the natural way to create the fraction between them using the electric line. So this is the, for example, experiment when many people do some experiments, for example, with one maggraph counterclockwise, another clockwise, and they put to the different corners in a room, and it was quite interesting effects. Sometimes was warmer in a room, sometimes was more windy, depends on your gases and way how you actually connect the maggraphs. So I've actually recreated the same situation. Instead of build two maggraphs, just let's try combine all this functionality in one device, because we get all this functionality inside this device. This is only logic, because capacitor is not the physical shape, is logic behind, is some situation what I like to achieve. And for me, it doesn't matter. I'm gonna achieve this situation with a square piece of wire or rounded piece of wire or piece of metal sheet, completely, flat piece of sheet, because it doesn't matter. The most important is the interaction, the way how the things will happen, not the why they happen, because if you got enough imagination, enough time, you probably will find thousands of ways to extract the field in many cases. So it's not only one way, and I think it's kind of, for my mind, it's always too toxic thinking about the one way. It's always the most healthy way. This is to take everything, deconstruct everything to the three-dimensional structure and think about, okay, I get a bunch of field here, I get a bunch of field here, and I get something like a spinning ball in front of me. And this ball, let's use inside, because inside this ball we get this kind of type of field, and outside this ball we get this type of field. So let's use the inside to for example put some interaction here. Let's use the outside to open some other different interaction. This is a way of thinking. I mean, like a part of the system. So if I'm gonna connect something through the electric system, like my plus, and this plus traveling across the system, I know I make the vibration from the system. That's my first field. this is like transmutation. You just come with normal AC, for example, and come out with plasma field. So, and on the way back, I got plasma field plus extra fields made by all the devices, by all the piece of wiring, steel and copper and zinc and brass inside all this electrical equipment. When I connect through the load by all the load, but this is still plasma condition. So if I on the way back, I just try opposite interaction, and so and this backing this field on the way back always just push the other interaction, something like that. I mean, I don't know. This is a clear enough explanation. There's a lot of arrows, that's for sure, on the screen, and
works for me.
I just the idea is actually pretty much extremely basic. I was trying kind of familiar interaction, the way how I gonna catch same field but with the different directions, because I got same field, same parameters. So if I gonna do the traction between the field, maybe I will gonna get what I'm looking for the really nice reduction and the really nice fields who actually work with your health in your house and stuff like that. So and give you a bigger field. I don't know. We need to check this. That was the explanation. And this maggraph supposedly should behave like a kind of streamer and receiver for other maggraphs inside your home. So the other maggraphs connect through your electric system. After a few seconds, when you're gonna connect this stuff, they supposedly should go higher. It's like an amplification for all your maggraph system. This unit, they behave like that, like an extra amplification for every single maggraph inside the circuit. That's found the conclusion too. Anyway, so that was the short explanation.
Thank you, Thomas. Thank you.
Yes, thank you.
Thank you for patience. Thank you for patience once again. All right.
Thank you for the nice pictures and excellent annotations and so on, and descriptions, and all of it is very good.
I showed the last thing. I got one photograph for you guys on the end in terms of how beautiful look nanostructure when they form itself. This is brass, and I just take this brass in the middle of the nano coating process by caustic soda, and all these small countries, lines, rivers. It looks like a real photography from the airplane. It's so beautiful, and this is us fields basically. That's how we look. That's who we are, but in a different state of matter, because this is the fields forming top of the brass plates.
Yeah, some of the pictures of Mars look similar.
Exactly. Everywhere the same. Like Mr. Mahram mentioned many times, the cosmos is the universe work on the same base. Everywhere is the same thing, and that's what we think on the even on the nano coating piece of metal, for example, structures like that. It looks like amber, very amazing, and the flames like on the red hot cars.
Wow.
And you see the field. That's one of the most interesting fields of photographies, because you see the forming fields. You see the interaction. You see the darker line, and after lighter line and darker. That's
very much like Jupiter. The shots that we see of Jupiter and sometimes Saturn are very similar.
Exactly. That's the way how I feel the fields when I use my hands. You feel this moment when you get the dark spot, and you go to this moment when you get lower gradient, when you field is slower, and after then you get next boundary, and then next slower place, and the next boundary, and this is how they look in real environment. Same fields, but manifest itself on a piece of metal. It's the beautiful flames. So that's all.
Most excellent. Beautiful. Okay, trying to wrap things up here, but is there any other comments or people would like to show something? Mark, you usually have something, but I'm wondering if it's a bit late or how are you doing there? Of course, like you say, you could always show something, but maybe you were it's a bit late for you as well. Okay, well, anybody else with anything they'd like to say or suggest? Comments, questions, and otherwise. There was a thing from Jay earlier. Could the Keshe Plasma Reactor Group start a GoFundMe donation page for research to create lift a bit quicker so some of the long-term members like you, Lee and Denny, could get materials a bit quicker? Well, materials is one thing, but I've had materials for quite some time. It's finding all the time and energy to focus just on lift as opposed to doing admin for Keshe Foundation or scratching out a living for myself to be able to survive or whatever. It's all takes time and energy away from that focus on creating lift. I'm hoping for sometime in the near future to be able to get into that more actually and actually set up a lab and focus more on that as an objective. We have to have lots of money because once you start getting into it, you need to have the backing. Otherwise, the enthusiasm can rapidly get lost as you try to flounder around with things that aren't correct and so on. So it's a good point, but I'm not into a GoFundMe for that particular thing, but it's something you might want to start and we could promote it and get it going. You had a good idea in the location where you are to get a what do you call it? From the Back to the Future, the car from the Back to the Future.
DeLorean.
DeLorean, that's right, thanks. And that's a noble goal as well, to get DeLorean flying. The Keshe technology, that would be excellent. So we'll work toward that. Okay, I think that's going to be it for today. I know I'm feeling pretty much tired, but that was a really, really great session. Thanking everybody for participating and you know, we had a lot of information come out that was just dynamite. So very good, folks. Thanking you all so much. Another great session, and it's over and out for Keshe Plasma Reactor Group for what's now Wednesday, June 14th, 2017. Anything you'd like to say before we go, Guy?
Good night, everyone. Wherever you are, let's see you next.
Right on. Okay.
I want to say good morning because
yeah.
Now we are in the morning.
Okay, very good. Yeah, it's the wee hours of the morning here at almost 3 o'clock in the morning.
So good night. Have a good night.
Good night, good morning, good afternoon, whatever is required.
And have a good plasma time.
I don't know what they say out in space because it might not be morning, noon, or nights that are even relevant out there. So
good.
Good luck.
The good plasma, good plasma time.
Miners, they also don't see the sun.
The good plasma.
Yeah. Is that what miners say when they go into the mines? Just good luck?
Yes, sure. Everywhere in the world. You need a little luck to come out at the end of the day.
True, but in theater they say break a leg when you go out and stage. That's to give you good luck.
Same like a sailors. They always
what do they say?
lose your boat.
Lose your boat? Yeah, like hope your boat sinks.
Yeah. Lose your boat sinks.
And that's it's sort of a good luck omen in a way. But yeah, saying the opposite can actually bring about the opposite sometimes. So it's one of those cosmic laws. You have to know when to say the opposite or to say the correct thing.
So have a good plasma with you.
Yeah,
that's a good one.
May the plasma be with you.
May the plasma be with you. That's a good one. Oh, Jedi.
Yeah, that's not bad. Eh? May the plasma be with you. All right, well, we're getting giddy here, so it's time to go over and out. And once again, thanks everyone.
All right, guys.
And bye for now. I'm going to end the live stream. See you all next week, hopefully. And for more of the same, and I want to see that lift. We'll get there yet. Okay, I'll end the meeting. Bye-bye, everyone.